Let me share my screen and then we'll begin the session. Okay. So, a quick introduction, since this is the first class session, your rank for statistics 2 subject. Okay. So, my name is Ram. Okay. The full name is Devani Ramanderu. I am one of the course instructors for Stats 2. Okay. And in this session, we look at the activity and the practice assignment questions. Okay. Is that fine?
Yes, right, sir.
Yeah. So I hope by now, since it has been like 10 days, since the content has been released, I hope all of you have looked at the content and have tried solving the problems. Okay. Am I right? I hope all of you have looked at the contents. Have you looked at the contents?
Sir, I am confused about the extra activities. How do we do them, submit them, and what was that creating that site for Stats2 page, a Google site, and then a Stat2 page, and write a table, draw the result. So how to do it, the extra activity?
Okay, so this session is entirely dedicated to this activity and practice assignment, and then the extra activity, right? Whatever questions you have, I hope there is this. You can post it in Discourse, and then there it will be answered by the other course instructors. Okay, so I'm not completely aware of that. Okay, so I'm not the right person to answer it. All right. So I hope you understand this.
Yeah, okay, fine, sir. No
Please
problem.
post it in Discourse, and then the
Okay.
instructor will be answering.
So sorry to interrupt you. So basically, I want to know that there will be 3 classes, dedicated classes for the stats 2. So can you please tell us that what will be going to cover in these 3 days?
These 3 days?
Yes, sir. So means today is the first class, and the other 2 classes will be for week 1 only.
Yeah. So the entire the entire sessions are going to be for week 1, and in this session we are going to discuss the activity and the practice. Okay. And in the next 2 sessions, one is going to be the open session.
Okay.
One is going to be open session where you can ask like any doubts you had in the concepts or anything. And then the last session it's going to solve with us where we'll be giving you some specific problems. And then like you'll be solving along with the course instructors. Like you'll be asked to solve then and there itself. Like we'll be giving you some time, okay, and then you'll be asked to solve. Just like you would have seen this in the previous subjects you would have taken, right? Like stats 1 maybe. There also you'll be having this solve with us, right? The same way. Okay.
Okay.
Fine.
So can we shift the Sunday session to today, means open session today, because what I want is that we have to first clear the all concepts which were given in the week 1. Means anyone who has a misconception with any of the topics, then we have to cover. Then for the next session, we will be asking the question. What do you think about this?
Yeah, I agree with that. So, but then let me give you this. Okay. It's not the current down. I'll show you current down. So you could see here live session, right? Can you see this? Under this live session, first of all, are you able to see my screen?
Yes.
So under this live session unit, right? You could see here week one activity practice session, and then this open session, right? So this is the open session that was in the previous term. Okay, so you could go through this, and then most of your concepts will be cleared, I suppose. Okay, and if you still have questions, you can ask. Okay, so while we are trying to solve a particular problem, right? If you have a question related to that particular concept, we'll discuss it there. Is that okay? Because we cannot be doing both the things. Like this session is dedicated to this activity and the practice assignment problems, right? So I cannot be discussing both the concepts as well as the activity questions and practice assignment. Okay, so that is for that we highlighted another session. But maybe if every one of you think that open session should be there first, maybe from the next week onwards we'll follow that. Okay.
Okay.
Cool. Yeah, okay. So I just want to go through this portal once. Okay. I hope many of you might be aware of it. So this live session one, it is the new. Okay. So I hope this is added for every subject. And here you'll be having a live session from the previous term. Okay. So most of the doubts, if you have right, that could be asked by the previous term students, and then they might be covered. Okay. So please go through this live sessions one. All right. And then most of the doubts might be cleared. Okay. So what
Sir,
we'll do? Yes.
Sir, week 0 is necessary for all.
Week 0, what you could do is you could actually go through the slides. Okay. Like it will be better if you go through it. But then if you feel like you are like confident enough, then it's okay. Okay to skip. Okay. Like I would suggest you to at least look at the slides. Okay. Slides, and then wherever you feel like you're not aware of that particular topic, right? Then you could go to that particular timestamp in the YouTube video and then look at that. Okay.
Sir, is there coding also using Python in this stat 2?
Yeah. So that is there. That I mean, yes, that was it. Like what we do is just to illustrate the concepts covered in stats 2. Okay, we'll ask you to do some. I mean, it's not exact class, but then because we'll be helping you to do the coding there. Okay, so it's like using the coding, you'll be able to understand the concepts of stats 2, this distributions very easily. Okay, so that is
just for practice, or it will be included in the exam?
No, it is just for practice. It won't be included in the exam.
Okay.
Okay, that is like extra resource.
Sir,
Yes.
is the coding gonna be like file handling?
It might, yeah. It will not include the file handling as far as I'm aware of it.
Because according to like data, like we just have to put it in a Excel sheet. So I'm thinking file handling.
At least in the initial few weeks, there won't be any file handling involved. In the later weeks, there could be. Okay, but by then the lectures it will be covering all the concepts, okay, that are required, and then like we'll be giving you the kind of like instructions as to how to run the program, and then like how to execute it and all that. We'll be hand-holding you, so it is okay. We'll be there to help you. Okay, you need not worry about it. It is not a Python course, so even if you're not completely aware of Python, it's totally okay. All right. Fine.
Sir, what is file handler?
Yes, sir.
Yes, sir. Yes,
So, like in the course introduction, you could see this general instruction on the important links. Okay. So this is the calendar where you could see the calendar. Okay. So like if you could just add this to your Gmail, right? Then you'll be receiving the notifications like whenever you have a live session. Okay. And then this announcements will be there. Okay. This announcement you could have it here also. And then the course playlist, it is the YouTube videos. Okay. These are the live session YouTube links. This is for the current term live sessions that's going to happen, right? You could here get the YouTube links. Okay. You could just go through each of this. And then this is for the grading pattern. Okay. All right. Okay. We'll move on to week 1 now. And then like how do you want this to be done? Like there are like 2 ways to go about it. One is you could mention all the problems where you had doubts, and then like I could solve them, or else I could solve each and every problem straight away. Like
Can I make one suggestion?
which one is okay for you?
Please solve these problems, sir.
Actually,
Like you
before
want me to
solve
solve
it,
each and every problem?
Yes, sir.
Okay. Then.
Sir, I think
think
if you will, firstly you take the selected problem, and then after, if you have time, then you can solve every problem.
Yes, sir. Selected problem.
Okay, we'll do the opposite. Like what we'll do is we'll try to solve the first AQ 1.1. Okay, based on the pace, I mean based on how much time it takes for us to solve the activity question 1.1. Okay, based on that we'll take a call on like to solve all the problems of the like next activity questions, or like just to solve a few. Okay, I mean based on how
Sir,
fast
even if you are doing even if you're doing 1.1 activity, then do some selective question only. If you do 1.1, 1.2 like, and if we have doubt in 1.5 or 1.7, then we will be not able to do it, no? So
Yeah, that's what I'm
it will
saying.
be good if you are doing some selected problem, and then after you can say that now you guys can, do it on your own.
Oh no, like yeah, I was saying that we'll solve all the specific problems here. Okay, but then if it is possible for us to solve all the entire problems, why not solve all the entire problems? That's
Yes,
what
sir.
I'm saying.
Yes, sir. Because,
Yes, sir.
because
We'll
it
solve-
helps in preparing for the anthem exams also, side by side.
Yeah. So what I'm saying is we'll solve AQ 1.1. Okay, based on like how much time it takes. Okay, since it is a 2-hour session, suppose it takes like more than half an hour, then it's not a good idea to solve all the problems. Okay, then we do what you said. Okay, but if it has taken
Okay,
very
you
less
carry
time,
on, sir.
okay, then we can solve all the problems, right? So that covers each and every problem. So it's good for you. All right.
Yes.
Okay.
Yes, sir. Yes, sir. This
Hello,
way,
sir.
concept building will also get along with the problem solving. This is a very good idea
Yes.
to solve each and every question.
Yes, yes, each and every is required, sir.
Yeah. So
In the
but then
beginning, each and
it
every is
depends on the
required.
pace. It depends on the pace, on the number of questions we have. So yeah, but then let's start. Okay. Okay.
Hello, sir.
So,
Yes, sir.
we-
Let us move ahead.
we don't discuss the concept here, like
No, we do not
for
discuss the
week one.
concepts. If you look at the live session name, right, it shows activity questions and
Okay.
practice. So we are going to discuss the activity questions and the practice questions. Right?
Okay, so there will be a session for that also. no?
Yeah, that is going to be there. That's going to be there for the next live session. Okay, in the open session, we are going to discuss the concepts.
Okay.
So
Okay.
what about
Actually-
Thank you, sir.
problems?
What about?
So what about week 0 activity questions?
Yes, sir, I had
we-
doubt, sir.
we are not going to
Sir, I
discuss.
wasn't able to solve some.
Yes, I also, sir.
Okay, what we'll do is
Even I have some doubts from week 0.
okay,
Yes, I have
we'll
it, sir.
do is- Okay, our primary concern is week 1, so we'll try to complete the week 1 first. After that, if you have
Yes,
time,
sir, yes,
we'll
sir.
get the week 0. Okay.
Solving all the
Okay.
Yes, sir. Yes, sir. Let us move ahead.
So then why it is
Sir,
given
I
in
have-
week 0?
See,
Sir, I have a
If
question.
it is given week 0, and we will not fill week 0.
Yes.
Sir, how can I revise the topics covered in previous terms? I mean, I want to access the course of Stat 1, but I am not being able to access the
you'll
course.
you'll be able to access, and this is operational query, so you should be able to access it. Do is you could post this question in the description.
It is accessible
No, sir,
in the
whenever
completed
I-
courses. It is accessible in completed courses. Go to
No,
completed
sir.
courses.
Whenever I go to the completed course page and I click on the go to the course page link, it says you are no longer subscribed to this course and redirect to dashboard.
You can write a mail. It will be corrected. No?
Yeah. So yeah,
Actually, log in
Thank you.
this
using
is
your
a
previous
operational
email
query.
ID.
So you better post this query in the discourse. Okay. So we will take
Can
care
I
of it.
suggest one thing? Can you first discuss a little bit of theory part, maybe for half an hour before starting the activity question?
The thing is, if we discuss theory part, it's not going to take just half an hour. So it's going to take more than that. So that is why what I was suggesting is we'll solve the problems. Okay, we'll solve the problems, but while solving the problems, if we like
Okay.
anyway we are going to get those concepts right. So I will discuss about the concepts there too. Okay.
Okay.
Not
Then,
like
Okay, sir. That's a great idea, sir. Right.
But sir, for
Yes, sir.
the
Yes, sir. Let us move ahead.
but sir,
let's
for
just do that,
coming
okay?
weeks, please do that session first, like concept
First,
session
better.
first. Then
Yeah. We'll do that.
Actually, what the person is suggesting is correct. Even the
Yeah. I do agree on that. We'll do that. Okay. So,
we will
but
swap Friday session to theory part and Sunday session for activity question.
yeah. That's what I was trying to say. I agree on that. We'll try to do that. Okay. So let's move ahead. Okay. We are on the
Yes,
same
sir.
page there. Okay.
Yes, sir.
Okay then. So
Excuse me, sir.
Yeah. What's it about?
So please, so sorry to interrupt you between. So please consider, sir, some parts of week 0 also, sir.
Yeah. As I told again, right? Our primary concern here is week 1. If you have time, we'll discuss week 0. Okay. So after this, if any of you have questions, please post it in chat box. Huh? because we are like getting interrupted too much. Already 15 minutes is done. So please cooperate on this. Thanks. Okay.
Sir, obviously this is very new. That's why we are, asking.
Yeah, I agree on that. So
yeah, that's a new policy. First time we are seeing.
Okay. So experiment. Okay, we look at the first question. Experiment consists of rolling the unbiased die. 2 times. The random variable xi is uniform. Okay, like, and then represents the number on the ith row. Okay, and then I equals to 1 to 2 because we just roll the bias. Okay, I'll mute others. Others, please mute yourself. Thanks. Okay, so here xi basically means that xi is like uniform. Okay, it's like uniformly distributed. The outcome of rolling of a die is like uniformly distributed, which basically says all of this have same probability of occurring. Okay, and then this I represents the ith row. Since we the experiment consists of rolling a die 2 times, I will be equals to 1, 2. Okay, so what they're asking is they're asking for the joint probability of like 3, 2, right? Okay, which basically means x1 equals to 3 and then like x2 equals to 2, right? So now what does this say? And then what we know is since it's like rolling unbiased at 2 times, okay, we know that it is like entirely independent, right? Okay, the first roll is like independent of the second roll. So basically this fx1 this f of 3, 2 is it's going to be equals to f of x1 equals to 3 multiplied by f of x2 equals to 2, which is nothing but probability of die outcome equals to 3 multiplied by probability of die outcome equals to 2. Okay, and then now since we know that it is like uniformly distributed, okay, we have this probability of probability of probability of xi equals to 1, 2, 3, 4, 5, 6. It's all going to be equals to 1 by 6. Okay, which basically means fx1 of fx1 equals to 3 is going to be 1 by 6. Fx2 equals to 2 is also going to be 1 by 6. So the overall joint distribution probability it's going to be equals to 1 by 6 into 1 by 6, which is going to be 1 by 36. Okay, first question is clear?
Yes.
Okay, fine.
Yes, sir.
Okay, the second one.
So,
yeah.
So, will it be possible for you to write on a notepad and explain?
Okay.
Yes, sir, that would be better.
Thank you, sir.
What they're asking for is this, they're asking for fx1 equals to what? 3, right? And x2 equals to 2, right? Since x1 and x2 are independent, what does this mean? This it's going to be the fx1 of like x1 equals to 3 multiplied by fx2 of 2. Okay, and this right, since we know that xi is like uniformly distributed. Okay, xi is like uniformly distributed with 1, 2, 3, 4, 5, 6, right? So the probability of any of them it's going to be equals to 1 by 6. Okay, I mean probability of xi equals to 1 or 2 or any of this equal or 6, right? It's going to be equals to 1 by 6, which basically means this probability of x1 equals to 3 is going to be 1 by 6, and this is going to be equals to 1 by 6. Okay, so total joint probability of x1 equals to 3 and then x2 equals to 2, it's going to be equals to 1 by 36. Okay.
Why you multiplied it?
Yeah, we have multiplied it because the first x1 and x2 they are like independent. That is why we have multiplied it. Okay. Fine. Okay, we'll move on to the second problem now. Now what we have is the joint probability mass function is given of 2 discrete random variables x and y. All right. Which of the following are possible values of a and b? They are asking. Okay. Now what are the conditions we have for a joint distribution table, right? What are the conditions do we have? Like for example, we have here this table, right? So
Sum is equal to 1.
yeah, sum equals to 1, correct?
All the entries should be greater than 0.
Yeah, correct. So let us do the sum first. Okay, so We'll do this 1 by 24 plus 2 by 24 plus 3 by 24 plus 4 by 24. It's going to be equal to 1 plus 2 plus 3 or 6, 10. Okay. 10 plus 11, right?
12.
Plus this is going to be what? 12, right? Okay. 12 by 24, right? So
yeah,
if it is equal to 12 by 24, what does that say?
A plus B, 1 by 2.
Correct. Okay. So, and then, yeah.
1 by 2 plus A plus B
which
plus
basically means
1.
if the remaining sum is equal to 1 by 2, then this A plus B sum should be equal to 1 by 2, right? Because
Sir,
the total sum should be equal to.
Sir, how it is possible 1 by 24 is equal to 1 because probability mass function, all the entries, if I sum up, is equal to 1.
Yeah. The sum up equals to 1. What I was saying is all the remaining ones except for A plus B, sum is equals to 1 by 2. Okay. Which
And
basically means
every individual entry should be greater than is equal to 0.
Yeah.
Then second and third row, there is the entries of 0.
You said that greater than or equal to, right? So it could be equal to 0 also.
Okay.
You yourself said that it should be greater than or equal to 0. So it can be 0 also.
But in the third row, it means 1 by 24 equal to 1. How it is possible?
No. 1 by 24 is not equal to 1. See, this is not the marginal one. See, all the sum of this individual element, individual entries, right? It should be equal to 1. Not the entries of the row or a column. Okay. The total entries of all rows and columns, right? That
If
should be
it is
equal
a matrix form, then I should sum up all the entries. Then equal to 1. Okay,
yeah.
thank you.
Okay. So now that we have this total sum equals to 1 by 2, which means the remaining sum, right, which is the unknowns A plus B sum should be equals to 1 by 2. So let us check this. The first option is correct because 1 by 2 plus 0 is equals to 1 by 2. Second option is not correct because it's going to be more than 1 by 2. Third option is correct. 1 by 6 plus 1 by 3 is going to be 3 by 6. So 3 by 6 is 1 by 2. And then fourth option is wrong because that's when, if it is equal to this, then sum is going to be more than 1. Okay.
So how you calculate B actually?
No, there is no. We only know the condition of A plus B equals to half. Okay. We only know the condition of A plus B equals to half. I do not know exactly what the value of A is. I do not exactly know what the value of B is. So
hit and trial method. Hit and trial.
Yeah, it can take like any value. So that is why we have this A and B both are correct. The only condition I have is A plus B equals to half. Okay. And this A and C option, it is satisfying that. Okay. Based. Okay. Clear?
Yes, sir. It is okay, sir.
It could be like A equals to 1 by 8 and then B equals to something like 3 by 8 also. Okay. Even that satisfied. All right. Okay. We'll move on to the next problem.
Yes.
From a well shuffled deck of 52 cards, 4 cards were selected at random. Let the random variable X denote the number of queens drawn. 4 cards were drawn at random. Okay. Alright, and at the random variable Y denote the number of kings drawn. Okay. What they're asking is they're asking for the f of x by 2, 1. Okay. Alright. So what does this say for us?
2 queen and 1 king.
Yeah. So what is the experiment for us? The experiment for us is drawing 4 cards, right?
4 cards. 4 cards.
Among these 4 cards, when we say like fxy of 2, 1, what does this say? X is what? X represents queens, right?
Yeah.
Y represents kings, right?
Yeah.
How many kings do we have in the 52 cards?
4.
4.
Kings, we have 4. What about queens?
4.
4, right? Okay, correct. So, and then what they're saying is, among these 4 cards drawn, 2 cards should be queen and 1 card should be king, right?
Yes.
Correct. So, basically our problem is finding the probability among 4 cards drawn. What's the probability that 2 cards are queen?
1 card is
queen. Okay. 1 is king.
1 is some other card.
Yeah, 1 is some other. I do not. I mean, it doesn't matter what it is, but it should be some other one. Okay. How do you choose it? Like among this, okay, among these 4 queens, right? I could choose any 2, right?
4C2.
4C2 and 4C1.
And then like, yeah, 4C1 because I could use like any king, like spade, spade, diamond, what are the ones? Hearts, clubs, right? Anything I could use. And then what are the remaining cards I have? 52 minus 8. How much is it?
44.
Okay, 44.
44.
Among this 44, I need to be choosing one because in total I should be choosing 4 cards, right?
Yeah.
Correct?
Yeah.
So this is my 4C2 multiplied by 4C1 multiplied by 44C1. This is the probability of, this is the probability of event of selecting kings and queens, right? But then what is the total probability of like selecting any 2 cards? It is 52C4. Correct? So
Yes.
this is our answer. And then let's check here. Okay, they are given the number. Okay, but then if you compute this, you are going to get the value. Okay, 4C is going to be equals 4 into 3 by 2 plus 4 plus 44 divided by
270725.
what? This is 27075.
Yeah.
Can someone compute this?
Sir, can I ask one question, sir? I have done it little differently. What I have done is 4 choose 2 divided by 52 choose 2 and then multiplied by 4 choose 1 because if I've already selected 2 cards, then 50 would remain. So 50
Okay, what did you say? You said like 4C2 multiplied by 52C2, is it?
Yes, 52C2.
Multiplied by 4C1 divided by 51. Sorry, 50C1.
Yes.
Multiplied by 4C.
And then
1 multiplied by.
Also, I did 1 because I have to choose 1 card and then 49 because 50 and then only 1 has to remain. So 49, choose 1 and 1 only. 1 divided by 49, choose 1.
This is the numerator is going to be 1 how?
1 by 49 because only 1
by
49.
1 by 49 how? That's what I'm asking.
Because I am choosing only 1 card.
Okay, you're choosing 1 card here, but here, right? Here you have like many options now to choose that 1 card in the numerator.
But sir, 44 choose 1 is 44. I'm choosing 40. Okay, out of 44. Oh yes, sir.
See, what you're saying is the first logic I agree with you. You're saying that I need to choose 2 cards. Okay, all those 2 cards I need to choose like queen. Okay, and then in the numerator you're saying among these 52 cards you choose 2. Okay, and then in the third one you're saying that among the
the 2 cards are already selected.
Multiplied by in the remaining 50 you choose 1, right?
Yes.
Here it's going to be now the remaining cards are what? 44 now. In the 44 you could choose anyone.
Okay, sir. Yes.
Now here it's going to be 49. Right? 49 C1. Okay. Ultimately this is going to be equal to this. Okay, both the same. All right.
I was not able to get that 44 C1, but now I get it because 4. Yes.
Okay. Your idea is correct, but then you just missed this part. Okay.
Yes.
If you just calculate this, the answer is going to be one of this.
Got it, sir. The answer would be same.
Yeah. Okay. Let's move on to the next one. Joint probability mass function of 2 discrete random variables x and y is given by gxy is going to be xy by 9, x comma y belongs to 1 comma 2. Find the value of p of x plus y equals to 1. Okay. So what they are saying is
So can I check something regarding the previous question?
Can I repeat?
Sir, can I check? Sir, regarding the previous question.
Huh?
Sure. So why did you do 44C1?
Okay, I did 44C1 because the last card it should not be king or queen. Because we mentioned 2 comma 1, right? When we mentioned 2 comma 1, the number of kings and queens are like fixed. Okay.
Yes, sir.
So we cannot be choosing again a king or queen. So basically,
So is it because? Sir, can I ask you what I understood, like whether it's correct or not?
Yeah, sure.
Sir, so basically it's the 4th card. I mean, 2 cards are for x, which is queen. 1 card is for king, And the last card has to be something from the rest of the pile.
Rest of the cards other than king and queen. Yeah.
Okay, got it, sir.
It should not be king and queen again, right? Because let's say you picked a king again, then it won't be 2, 1. It's going to be 2, 2. Suppose if you picked a queen, then it's going to be 3, 1. It won't be 2, 1, right?
Yes, sir. Yes, sir.
Okay.
Got it, sir.
Sir, I have another doubt here, sir.
Yeah.
Sir, by doing this, I did like this only. But after studying marginal and conditional, after seeing this question, I thought to do like that, but it's very difficult now, sir, like doing that way. Marginal and conditional using that concept.
That marginal and conditional, it's very difficult. That's what he's saying.
Yes, sir.
See, okay, I agree. Marginal and conditional, they are not so straightforward. Okay, but in this problem, right? Here, you need not worry about like worry about the random variables and then the joint one. Okay, all you need to think about is that among the 4 cards, what this represents. It represents that I picked up 2 queens and then like 1 king, right? And then the remaining card could be any other one, right? This is just a normal probability problem. Okay, the second problem, the third problem, you need not even have the entire knowledge of this joint distribution and all that, right? The normal intuition alone, it comes to you, right? All this means is that we picked up 2 queens, 1 king, and then the other one could be anyone. Okay. Here we did not use like any formulas of like fxy of this equals fx of like we did not even think of this independent one, whether this x and y are independent, all that. Obviously they are dependent here, but then that's a different question. But we did not use any of those concepts. Okay. What I want to say here is, for some problems you need not have to think of like, okay, I need to be using conditional probability, I need to be using this marginal probability and all that, right? You just think of it as a problem, think of it as like given one. I mean, what's given, what's required as output, and then like how to play around with it. Okay, so while you're trying to solve, you could be coming across a condition of like, okay, I need to be using this conditional probability to get the answer. Okay, or else sometimes you just need to be using this marginal one. Okay, but please make sure that it's not like you always need to use that conditional marginal. Okay, it's just a problem solution. Okay, don't overthink. All right.
Yes.
Okay, it takes time. Try to understand the problem. That's the important part. Okay. Okay. I hope I made some sense. All right. We'll move on to the 4th problem. So here what they're saying is gxy of x comma y, it's going to be equal to xy by 6. Here they're saying x comma y takes 1, 2 values. What does this say? First of all, let us look at this. I mean, let's look at what was given and then like what can we make out of it. Gxy of x comma y is equals to xy by 9, right?
Yes.
And then x comma y belongs to
1, 2.
Okay. So what does this say? X takes the values of 1, 2, and then y takes the
Y
values
takes the value of 1, 2.
Okay. And then which basically means gxy it could take 1, 1, 1, 2. Okay. 1, 2. That's it, right? Am I right?
Perfect.
It's going to be 1 by 9,
Yes, sir. Yes.
2 by 9, 2 by 9, 4 by 9. You sum it up, you're going to get equals to 1. Okay, you sum all this, it's going to be equals to 1. Sum all this, it's going to be equals to 1. Okay. Now, I mean, that is just a basic. You could write this probability distribution for the joint distribution table. You could write that. It's not required because it's easy, but anyway, I'll write it. So this is like first class. Okay. So what about this 1, 1? It's going to be 1 by 9, right?
Yes.
1, 2, it's going to be 2 by 9, right?
2 by 9.
2 by 9.
Okay, and then 2, 1, it's going to be 2 by 9 again.
1 by 9.
2, 2, is going to be 4 by 9.
4 by 9. 4 by 9.
Okay, and then what is our main rule for this joint distribution to be valid? sum should be equals to 1. Okay, this is going to be equal to 3 by 9. This is going to be equal to 6 by 9. The sum is going to be 9 by 9 1. Okay. Okay, total is okay.
Yes.
Fine. So what they are asking is, first question, x plus y equals to 1. They are asking, when can x plus y equals to 1 happen? When x equals to 0 and y equals to 1. And then we know that the probability for x equals 0 is 0, right? So there is no case of like x plus y equals to 1 to be happening. Okay.
Yes.
The minimum value that you could get of this x plus y is 2.
To minimum.
Yeah, minimum is 2, 3, or like 2, 3, 4. Those are the only possible cases here.
Yes.
Okay. So the probability for x plus y equals to 1 is 0. Okay.
Yes.
So, sir, I have a doubt.
Huh?
So, here is a capital X and capital Y, and there is a x small x and a small y means.
What does that say? That's your question. Am I correct? Okay. So what does this basically say is, this capital X, capital Y, they're like representing the random variable. Okay. This small x and small y, they're representing the particular value corresponding to a random variable. Here, right? Small x, small y value to take 1, 1, 1, 2, 2, 1, 2, 2.
Okay.
Right?
Yes, I got it.
Okay. Yeah, and then we have this p of x minus y equals to 1. Okay,
That is okay. That 2 by 9.
2 by 9.
Okay, we'll check for it. Okay. X minus y equals to 1, they're asking, right?
2 minus 1, 2, 1 is okay then.
Okay. So now we'll check for this. Here let's consider this another random variable as x minus y. Okay. What this x minus y values can take, it could take 0, minus 1, 1, right? Am I correct?
Yes.
Yes.
Okay, it could take this 0, minus 1, and then 1, right? So what do we have here? We have here, they are asking for x minus y equals to 1, right? X minus y equals to 1 can happen only when x equals to 2 and then y equals to 1. Correct? In this case, it's going to be 0. In this case, it's going to be minus 1. It's going to be 0 here. Okay. So what's the probability that x minus y is going to be equals to 1? 2 by 9.
Perfect. Right.
Okay.
Yes, sir.
All right. Clear?
Yes, sir.
Okay. We did one mistake. Okay. Here we did not solve this, so that's it. Okay. AQ 1.1 is clear.
Yes, sir.
We'll move on to the next one. Okay.
Sir.
We are able to solve it slightly. Okay.
No.
Try to solve.
Sir, in the last question, sir, the last one which we did, if it was that instead of x minus 1 is equal to 1, if it had been x minus y is equal to 0, then we would have added 1 by 9 and 4 by 9, right?
Exactly. Yeah.
Sir, hello, sir. Sir, when the concept of all week 1 will be discussed in which session?
It's going to be discussed in the next session.
Actually, Ram, when you move to activity 1.2, for 5 or 10 minutes, only the summary of 1.2 lecture can you discuss so that it will be, you can catch.
You want to discuss the summary of 1.2?
No, can you just brief the 1.2 lecture first, then you can start 1.2 activity. Is that possible?
Okay. So I'll try to brief it. I'll try to brief it in like 5 minutes. Okay. Clear?
Yes.
Okay, we'll try to do that. Okay. I'll try to use this table. Okay. Marginal probability. That is, before we get into that. Okay. This marginal PMF, right? That is nothing but the probability of a single. Instead of joint, right, we are asking for the output of like single random variable output, like probability of xi equals to x, something like that. Okay, like here in this case we are asking for the p of 1, 1, right? I mean gxy of like 1, 1, gxy of like 1, 2, gxy of 2, 1. Okay, I do not want that. But like before we used to look at this when we have this random variable, we used to look at p of x equals to 1, p of x equals to 2. Okay, this is a marginal distribution, right? This is a marginal PMF now. So how do you get this marginal PMF from a joint from a joint mass distribution, right? So how do you get that? The way you get it is, for example, if you want to get here probability of x equals to 1. Okay, where are all the cases it is happening? It's happening here, right? So the probability of this is the probability of p of x equals to 1 is nothing but 3 by 9. And the probability of x equals to 2 is nothing but this condition and this condition is going to be 6 by 9. Similarly, p of y equals to 1 is going to be 1 by 9 plus 2 by 9, 3 by 9. P of y equals to 2 is going to be 2 by 9 plus 4 by 9, 6 by 9. Okay. So basically, when we are looking for p of x equals to, let's say like xa, right? Okay. What do? We do for this sum of, let's say we have just 2 random variables. Okay. And then here we have, let's say this gxy. Okay. Gxy of x comma y. Okay. Instead of, we want to keep this xi as constant and then sum over all the yi values possible corresponding to this xi. Okay. Sum over of y. Okay. Sum over of y we want to take. All right. Something like we represent by ty, right? If I'm correct. Y belongs to ty. Am I correct in this?
Yes, sir. Yes, sir. You are right.
The notation I'm talking. I know
Yes,
the
notation right only.
The notation.
Professor also said
Here, look at what we are doing. When we are asking for this p of x equals to 1, we are summing over p of x equals to 1 comma y equals to 1, and then p of x equals to 1 comma y equals to 2. The same exact thing I represented it as a formula. Okay, nothing more we have done. Okay, this is the entire marginal PMF. Okay, nothing more than this. Okay, clear? Like if there's anything like extra complicated in a particular problem, I will discuss it while we go through this. Okay. Okay. In this particular case, we have only 2 random variables, x1, x2, and then they just give the probability mass function of x1, x2 they have given. They're asking for fx1 of 1. Okay. This is x1. Okay. This is x1, and then when they're asking for this fx1 of 1, basically we should be summing over this entire system. Okay. We should be summing over this entire. All right. As I have told, fixing this x1 equals to 1, we should be summing over all the positive values of x2. Like in this particular case of like 1, 1, 1, 2, 1, 3, 1, 4. Okay. If we sum over all this, it's going to be equals to 0.02 plus 0.05 plus 0.02. It's going to be 0.09, 0.01 plus 0.12, 0.21. Okay. So the first one is correct. Okay. A plus B plus C equals to 0.62. We know that the sum of probabilities of a random variable, it should be equals to 1, right? So yes. A plus 0.2 plus 0.18 plus B plus C should be equals to 1, which gives A plus B plus C as 1 minus 0.38, which is going to be 0.62. Okay. If B is correct, then C can't be correct. They're asking for K value. 4K equals to 1, which gives K as 0.5.
Correct.
0.25. Okay. First problem is all right.
Yes, sir.
Okay. The second problem, it is just a notation they are asking. I mean, whatever we have discussed the formula for marginal fx1 of t1, right? We should be summing over. We should not be summing over t1, right? We should be summing over t2.
T2.
So that's why option 2 is correct here. Here also, yeah, option C is correct because we should be summing over t1 here. Okay. If you want to get fy of t2.
Sir, actually, can you just teach us as to how to read that particular notation? Because
Yes, sir.
I'm not able to read the notation. I'm
Yeah,
not
yeah,
able to
okay.
decipher anything.
Okay. So this fxy of t1 comma t2, that's okay, right? The summation alone you're finding difficult to read and understand it. Am I correct?
Yes.
Here what they are saying is sum over all the possible values of t1 like in the entire range of this ty, which basically means they are saying keep t2 as constant and then like sum over all the possible values of t1. That's what they're saying.
Okay, T2 is constant and T1 you're summing it up.
Yeah. But that's not what you want, right? You want to keep T1 as constant and like change T2. That's what we have done. That's what they said in like option 2. They said keep T1 as constant and sum over all the possible values of T2 in the entire range of Ty.
Yes.
Okay.
Yeah.
Clear? Now it's clear?
Yeah.
Okay. We will use the same one when we have this more than 2 random variables also. Okay. All right.
Okay.
The probability mass function of two discrete random variables x and y is given as fxy equals to xy by 9. The same problem we have given. Okay. Same problem like we have discussed in the 1.1, right? fx of 1 and then like fx of 2 they're asking. So what is that say?
1.
Yeah. This without even thinking we could answer it, because all the possible values of x are nothing but 1, 2. If you are asking for sum of the probabilities of 1, 2, obviously it's going to be 1. Okay. It's like no brainer. Okay. I mean, if you think of it that way, it's like no brainer. But even if you solve it like the normally also, you're going to get 1. All right. Clear?
Yes.
Okay. We'll move on to 1.3. Okay, they're going fast.
So if I try to repeat what you said for last problem, you said that it is summing up all the values of x that x can take, the probabilities. That is why it is coming to be 1.
Correct.
Okay, sir. Thanks.
I mean, because let's say it is asking like suppose you are rolling a die, okay, and then if I ask you what is sum of probability of die outcome equals to 1 plus 2 plus 3 plus 4 plus 5 plus 6, it's going to be it's going to be 1, right? Because when you roll a die, obviously the outcome is going to be one of those 6 options. Okay, so sum of probability obviously equals to 1.
Okay, sir. Thanks.
Am I going too fast? No, right?
No, it's fine, sir.
Okay.
No, sir.
So from a well shuffled deck of 52 cards, 4 cards are selected at random. Let a random variable x denote the number of queens drawn, y denote the number of kings drawn. Okay, now we come across this conditional. Okay.
Conditional.
Okay. If you want me to discuss the conditional, I will discuss it. Okay. This is like, okay, I mean, I won't get into formulas because formulas is kind of like not so difficult, but then I will tell you what that basically means. Okay. Whenever we say this is this joint one, small y, okay, we have this 1, 2, 3. Let's say like 1, 2, 3 has happened. Okay. When I mention like effects of like, okay, what I was basically saying is y equals to 1 has already happened. Okay, y equals to 1 has already happened. When y equals to 1 has happened, what is the probability that x will be equals to 1? Which basically means is when y equals to 1 means that let's say this is like 0.1, 0.2, 0.3. Okay, this is some dummy values I have taken. Okay, so when you mention like y equals to 1, this has already happened. Okay, I mean this is like certain. The outcome is like y equals to 1. And when y equals to 1, they're asking what is the probability that x will be equals to 1, right? Correct?
0.
So basically this is initially all the, I mean initially we could have something like 0.5, 0.05, maybe it's going to be equals to 0.2, what 0.5, right? Maybe 0.05. Am I correct? This is for 0.3. This is 0.4. Okay. I'll make this as 0.1, 0.1. Okay. Now sum is equals to 1. Okay. Yes. Initially, when I say like when I say this f of x comma xy 1 comma 1, right? The probability of this happening is 0.1. Okay. Correct. But then if I say y equals to 1 has already happened, when y equals to 1 has happened, what is the probability that x equals to 1 will happen? Among these conditions, we should look for the case of this, right? Correct. Right. It is like saying, let's say, okay, we have countries, right? I hope all of you know.
Y has already happened, and what is the probability?
When that has happened, what is the probability that another thing will happen? Like let's say we know cricket, right? So we have countries playing from Europe. We have this England, Africa also we have, and then we have from Australia, right? Australia continent, and then we have from Asia. Okay, let us say a World Cup has happened, and then I'm saying that one of the Asian country has won the match. Okay, won the cup. When one of the Asian country has won the cup, what is the probability that India has won the cup? That is like, if I ask, then what does that mean? Like, I'll represent it this way.
Asia has already won, and in that India
winner equals to India when the winner is like Asian.
Asia.
Hello, can you hear me?
Yes, we can hear you.
No, sir, we can't hear you.
No, it's okay. Audible, sir.
Okay, yeah, I lost my internet connection, so
yeah,
I got connected through my mobile hotspot. Okay, so what is the probability that winner is India given that winner is an Asian country? Okay, this is a conditional one. What is this conditional basically means is like I was saying a particular thing has already happened. That's like I am giving you a condition. Here the condition is Asian country has won. Here the condition is y equals to 1. Okay, you're having so many conditions, right? Here also, this is like same scenario, right? Like this conditional one, it is not like new to us. It's like very common to us. Like suppose you entered IIT Madras. Okay, suppose you entered IIT Madras. What is the probability that you will get a package of like greater than 25 lakhs? Correct. So normally for any student, for him to get a package of 25 lakhs, that is different. But for IIT Madras student, it is different, right? What is the probability that a student has got 25 lakhs given that he is from IIT Madras? That is a conditional one. What is the probability that a graduate student will get 25 lakhs as a package? That's a different question. Okay, I have to understand the concept of like what I'm talking about. Okay, clear? Okay, like in this example, instead of India, let's say like what is the probability that winner is Australia given that Asian country is won? What is that value? Zero, right? Obviously, because when I said Asian country has won, there is no way that Australia is a winner. Okay, so in this particular case, you're saying same problem like before. 4 cards were drawn at random. Or saying let x denote the number of queens drawn, and let the random variable y denote the number of kings drawn. Like same, f of x given y equals to 1. Okay. So here what this basically means, here we know the formula, right? Here what is the formula?
P of x given y is equal to probability of x intersection y divided by probability.
Correct. Yeah.
Of y.
So yeah, it's basically like and y equals to 1 divided by probability of y equals to 1. Okay, I mean, this is nothing but what we are basically doing is we are basically doing this 1, divided by this probability of this, because this is our condition. Okay. Okay, so in our particular case, what is the probability? Okay, first let's look at denominator because we already looked at the numerator part. Okay, so this probability part, we could do it in the number of possible cases way also. Okay, so what is the probability that y equals to 1 will happen?
What is the pardon me, sir? Come again, sir.
What is the probability that y equals to 1 will happen? Kings, one king is chosen, right?
One
That is
king,
like
1 by 4.
4c1 multiplied by 48, 48, no, 48c3, right?
Yes.
Correct? I'm not,
yes,
okay, I could write this 52c4 also, but they'll get cancelled out. I'll explain why. Okay. This is the probability for y equals to 1, correct? Marginal probability. This is marginal probability. Okay.
Okay.
And probability for x equals to 1 and y equals to x equals to 2 and y equals to 1. This is like 4c2 multiplied by 4c1 multiplied by
44c1
divided by 52c4, right?
Yes, sir.
These two gets cancelled out. This is what you get.
One minute, sir. Here in the denominator 4c1 into 48 c3. How 48 is coming? I miss, sir.
I'll tell you.
Yeah.
Okay, so whenever we are saying that we have like one king, right?
Yeah.
One king is chosen, and the remaining three cards, it should not be king, right?
Yes.
Right. So how many kings we have in a deck of 52? Four kings, right?
Yes.
So among these 4 kings, I need to choose one, and then in the remaining 52 minus 4 is 48. No, from the remaining 48, I need to choose 3.
Oh yes.
Because the remaining 3 cards, it should not be king, no?
Yes, yes, and in one choice, right? Correct.
Yeah.
Yeah.
Okay. So like the the probability, the condition, here what you'll be getting in the numerator is among this 48c3, there could be some, there could be some choices where you'll be choosing 2 queens and like one card is the other one, no? Correct? There's like some probability. Okay. Clear?
No, sir. Please explain again, sir.
Okay. This is like
sir, I
what
have
I'm
a
saying
doubt.
is this 48c3 is our total options, you could say. Total number of ways of like picking 48. Okay. Let's remove kings. Okay, let's remove kings. We have now 48 cards, right? Okay.
Yes.
This 48 cards also include queens now.
Yes.
Okay. So from these 48 cards, I'm choosing 3 cards. Right. So in these 3 chosen cards, there could be some scenarios where 1 queen is chosen, 2 queens are chosen, 3 queens are chosen, no? Okay. Yes. That is why I'm saying like it is like subset. This numerator is subset of this. Okay. Obviously, that is true. Okay.
Perfect. Right.
If you do not understand this part, it's totally okay.
Right. So.
Okay.
Sir, I have a doubt.
Huh?
Hello. Sir, I have a doubt. Sir, actually, as we have studied about the independence in week 0, so what the role will play by independence in this case? How we can say that these are independence? How the formula differs when independence comes into the picture?
Okay. For this particular problem you're asking, or in general are you asking?
For this particular, as you can assume, so you can assume this question as well. How the independence comes into the picture, how it differs from conditional.
Like it's not like differ from conditional. We use conditional probability to say whether they are like independent or dependent. Okay. So when we have this p of x equals to 2 and then like y equals to 1, right? If it is equals to p of x equals to 2 multiplied by probability of x equals to 1, sorry, y equals to 1. Okay. If this is the case, then x and y could be independent. Okay. I'm saying could be. Please note this, could be, because if you take like any value of x and any value of y, this should hold, not just for x equals to 2 and y equals to 1. Okay. So that is why I'm saying could be independent. Okay, but let's say even for this particular case, this did not hold true. If it is not equal, then here itself we could say x comma y are not independent.
Can you explain the could be part again, sir? I'm not able to understand this could be.
Okay. So let's say like here we could, I mean, here I'm not calculating it, but then I'm just saying normally for some particular xi value and yi value, in this particular case it's 2 comma 1. Here let's say like I got this equals to p of x equals to 2 and then like p of y equals to 1. But let's say I took some other x value and then some other y value. In this particular case, it's not equal. Okay. In this particular case, it's not equal. So just based on this, you cannot say that they are independent.
Okay, there should be all the cases where this is proven.
Exactly. That is why I said could be independent. Okay. I did not say they are independent.
Okay, sir. Sir, I mean like conditional says ki this thing is happening only if this thing is happening. I mean other thing is happening, right?
So
and
how
independence is
correct.
Yeah.
How you use conditional to say whether they're independent is like one the event of like one particular random variable occurring does not affect the other random variable occurring. Okay, if they are like independent now, what this basically says is probability of x equals to 2, right? X equals to 2 occurring, it does not depend on the what the output of y is. Okay, clear?
Okay, got it, sir. Yes, sir.
If it is like dependent now, I mean if the value of the probability of x equals to x depends on the output of y, then which basically means they're like dependent. Okay, it's
Okay,
like saying the number of marks you get now, it doesn't depend on the number of marks I get. It basically means the marks you get and the marks I get are like independent. Okay, but let's say we both are friends and we study together. Okay, and then like the number of marks I get is kind of like dependent on yours, because if I do badly, maybe you will also do badly. Okay, but between two strangers, they are like independent. No, I'm just giving some random example. Okay.
Yeah, in general they're independent. Yeah, in general they are independent.
Yeah,
Otherwise,
in general,
depending
they are
on
like
conditions,
independent.
what is given the question. Yes, got it, sir. Thank you, sir.
X comma y equals to fxy of t1 comma t2. Identify the correct statements on the following. Range of x y equals to y given x equals to t1 will always be the range of y.
Yeah.
That need not be the case. Okay, that need not be the case. Range of y x given y equals to t will always be the range of y. This is definitely not true, because the range should be subset of x, not the y. Range of y given x equals to t1 can be different from the range of y. This is true.
Correct.
Because
yes,
this could happen because there are going to be some values of y, okay, for which the conditional probability is 0. Okay, that is why the range of y given x equals to t will be subset of range of y. Okay, you could follow the lecture if you did not mention what I said.
Sir, I have a question here.
Here,
when we're saying range, does it mean the values that this y?
Yeah.
Okay. But it will fall within the range of y.
Yeah.
In the difference in the minimum and the maximum value, but it may not necessarily be the same.
Correct. Okay, we'll move on to fourth question. Xy equals fxy of t1, t2. Choose the correct options. T1, t2, x given y equals t2 multiplied by correct. Okay. I mean, this is nothing but we told now. This fxy of this x given y equals t2, right? X equals t1 given y equals t2 is nothing but fxy of t1 t2 divided by fy of t2. So they just like rearrange that formula. So you get the first option, fxy of y given x equals to t1 multiplied by this. This is also correct. Okay. Instead of conditioning with respect to y, in the second option they condition with respect to x. Okay. This is like I'll tell you what that means based on what we have given. Okay. This particular value, okay, this particular value, this is 1, 1, right? This 1, 1. I could condition with respect to y equals to 1, or I could condition with respect to x equals to 1. Okay. That is what the first two options mean. Right. T1, T2, x equals to T1 and then multiplied by y of T2, fy of T2. That's not correct. Okay. We should be multiplying with the probability of x equals to T1. When you're conditioning like f of y equals to T2 given x equals to T1, right? That should be multiplied with probability of fy of T2. Sorry, fx of T1. Okay. Option number 3 is incorrect. Sum of T2 belongs to Ty, fy of x equals to T1 of T2. This is 1. This is correct. Okay. Are you aware of like why option number 4 is correct?
Can you please show it in the diagram, sir? That table.
Yeah, sure. So let's take this example again. Okay, this diagram is like very clumsy, and I'm sorry for that, but we'll go ahead. So here we talked about fxy of 1, 1. Sir, there's fx of 1 given y equals to 1, right? Correct. So here in this particular case, what they're asking is they're asking you sum of y belongs to ty. Sorry, since we are doing with respect to y, let's do it like x belongs to tx. Okay, fx given y equals to 1 of x, right? X comma 1. Okay, they are asking this sum, correct? What does this basically mean is we know that what is this probability value? This formula is going to be fx x equals to xi and y equals to 1 divided by fy of 1, right? Correct? Am I correct with this formula? Write it here. X belongs to ty and then fxy of x given y equals to 1, let's say. Okay. X. They're asking for this. Okay. What this basically means is what this basically means is what does this mean? What is this formula? It's nothing but fxy of x comma y divided by fy of capital Y, right? Sorry, small y. Okay, fy of y, right? This is a formula, correct? So when we are summing over, when we are summing over this with respect to the entire x values, which basically means you are doing this fxy of x equals to, let's say, xi comma y plus fxy of x equals to x2 comma y plus and so on divided by fy of y, correct? But what is this? What is this sum? This sum is nothing but the marginal PMF, right? Marginal PMF of fy of y, no?
Yes, sir.
Correct.
This is the
So
marginal. Yeah.
the numerator is going to be fy of y divided by fy of y, which is going to be equals to 1. Okay. All right. Let's look at these two problems now. X and y be two random variables and the PMF is given. The joint PMF is given. Find the range of y given x equals to 1. Y given x equals to 1. When x equals to 1, the
to 3.
2 and 3.
the probability for 1 comma 1 is like 0. That is why when y equals to when x equals to 1, the y can take only values of 2 comma 3. Okay, so the option will be like 4. Calculate fx calculate the probability that x equals to 1 given y equals to 2. Okay, so given y equals to 2, y equals to 2 is this, right? This no? The probability for y equals to 2 is, the marginal PMF of y equals to 2 is 0.3. Okay, and then the probability of x equals to 1 and then y equals to 2 is
1.
X equals to 1 and y equals to 2 is 0.2, no? So it's going to
0.2
be
by 0.3.
Yeah, 0.2 by 0.2, 2 by 3. Okay. All right. We did not solve the first problem. We solved it, but then we did not compute it. Okay. Okay, we are good to go. Okay. So this lecture 1.4, that is just nothing but the examples. Okay, whatever we have seen, the conditional, the marginal, and the joint PMF on. Okay, but including this Poisson one and like having for the normal common distributions. Okay.
Sir, it is better to discuss Poisson distribution, sir. It was really not understandable for me.
Okay.
Yes, the same here.
Lecture 4 was little tedious, sir. During our lecture, we were not being able to understand it in much clarity. So either you will please convey or revise it again if possible before doing these activity questions.
Okay. Okay, fine. Okay, so here I'll be discussing this Poisson distribution.
Sir, first discuss the concept, then arrange the activity question session. Then it will be better.
Yeah. We'll do that. But for now, let's just do this. Wait. Okay. So I guess doing it in this way is also not bad, because whenever you look at the concepts, right, you'll always be listening entirely. Like you'll always be listening entirely. You won't be actually applying those concepts. But in this way, now, like I'll just be discussing few minutes about this Poisson distribution, and then we'll be solving the problems. Okay. In this way, you'll actually be able to, like, whatever you understood in between, you could actually apply it directly. So you'll be able to remember it like well. Correct. As compared to, like, let's say I discuss the entire concepts today without solving a single problem, and then tomorrow I took
Sir,
this.
if we understand concepts from the videos, then what you're saying is correct. But sometimes it so happens that we are not able to understand some of the concepts in the video.
Yeah, I agree.
Like
so,
the example given in this joint, marginal, and conditional one, the video which you just now told, it just has example. It has the example of Poisson distribution, and actually the application of it, seriously, I didn't understand.
Okay. Let's discuss this Poisson distribution first. Okay. Poisson distribution for x equals to, let's say, like I, right? It's going to have some parameter for the
Lambda e power
lambda, right? Yeah, lambda for the Poisson distribution. Okay. If we have the parameter, then the probability for x equals to y, it's going to be equal to c power minus lambda into lambda power k by k factorial. Okay.
Yes.
So, like,
is lambda meaning probability? What is the meaning of lambda, sir?
what lambda is a parameter for this particular Poisson distribution. Like every Poisson distribution has this parameter lambda. Okay, that's like unique to that particular Poisson distribution. All right,
Sir,
like
It doesn't mean probability.
no, it does not mean the probability.
Okay.
You actually
it means I guess the average. I mean the mean of the whole probability. I guess the
Mean of
lambda
the
will
actually the mean.
It's the rate of occurrence of an event.
Correct.
And it's
Yeah.
constant for Poisson distribution.
yeah. It's basically the mean
The
of whole
mean is going
experiment.
to be 1 by lambda if I'm correct. Not lambda, it's going to be 1 by lambda. Okay, but let's come to this. Okay, so based on different values of lambda, right, we'll be getting this this one. Okay, this distribution. Okay.
It is the rate of what, sir? I couldn't hear, sir.
Rate of
It's
change.
like the inverse of mean, you could say. Okay, lambda, the rate of occurrence.
Rate of occurrence. Okay.
Yeah. So for now, consider it like a parameter that kind of like that is used to represent a Poisson distribution. Okay. So if you look at this series, lambda for k by k factorial. Okay. Let's the I values it could take only positive or like 0. So it could take from 0 to infinite, 0, 1, 2, and so on like infinite. If we sum over all these probabilities, it's going to be equals to what? Reduce sum over I equals to 0 to infinity. Yeah, it's going to be equals to 1. I'll tell you why. Because it's going to be equal minus lambda into first initial it's going to be what? Lambda power 0 divided by 0 factor. One.
So your voice is breaking.
Yeah. It's going to be equals to lambda power 0 by 1 factor plus 0 factorial plus lambda power 1 by 1 factorial plus lambda square by 2 factorial plus and so on, right? This series have you noticed somewhere?
It should be
Lambda. With e power lambda series, right? So going to be e power minus lambda and e power lambda is going to be equal 0, 1. Okay. Fine. Okay. I mean, when this
Sir, we can also use the logic, sir. All the distribution, I mean, all the probabilities will obviously be adding up to 1.
Yeah. Obviously, but then I just want to show that if you know the e power lambda series expansion, how this formula came upon, like how the sum came to e power minus lambda. Okay. Why this e power minus lambda came in the formula? I just want to explain that part. Okay. So okay, let's move ahead. So when this let's say like this I happen, that is the outcome is like I read like it's like if you're counting if this I represents the number of people that visited our hospital, okay, or number of dice thrown. So if you're asking for px of I, which basically means if you're taking of dice, the probability for I dice to be thrown. Okay, that's what it means. And using that we have done for the I mean we use the die not the die, I guess. We use die or like head now. We use for head, right? Coin toss we are used, right? Okay, yeah. Like when you toss the coin like I times, okay, when we toss it on for I times, what's the probability for us to get like k heads? Okay, first it should be equals to I, and then the number of outcome of heads now. This if I represent it by random variable by, okay, if I'm counting the number of heads occurring, then it should be what, y equals to k, right? So what is the probability for this to happen? These two are like independent. Okay. So we have here e power minus lambda power I, lambda power I by I factorial multiplied by here among this when we're tossing this coin like I times, okay, when we're tossing the coin I times, in that what is the probability that you get k heads, right? This is binomial distribution. No? So we have here ICK, right? In that, let's say if it is this, if it is a fair coin, then the probability is going to be equal to half power I. Okay. And then if it is not a fair coin, then it's going to be instead of half power I, it's going to be
P and 1 minus P.
Yeah. P power K into 1 minus P power I minus K. Okay. This one it's going to be. All right. This is the joint probability. Okay. Joint probability of X and Y. All right. That is this the probability that we have tossed like I coins, and then I coins like means the outcome of this Poisson distribution is like I. Okay.
Sir, in the question, the value of lambda will be given, or we have to find out the value of lambda.
Value of
Here
lambda
I is given.
The value of lambda will be given.
Okay, fine.
Okay. So once we know this, we have this we have this joint distribution. Now from this joint distribution, sir has done the marginal one, that is the sum over for this. I mean, for P of X equals to I, that's like direct. Okay, that's like direct because we directly know this. But what about this Y equals to K? Py of this Y equals to K. Okay, that's not like directly. I mean, that's not very straightforward because this KH could be happening from like, for KH to happen, obviously the minimum number of points that should be tossed is like K. Okay.
Yeah.
So from K it could go to infinite also, right? I mean,
minimum is K.
Yeah, minimum is K. I'm sorry. Okay, so minimum is K. So what
why is minimum K?
What?
I didn't. Why is minimum K?
Yeah, I is minimum K. Sorry, X is like minimum K. Okay. So this X value take like K plus 1, K plus 2, and so on like infinite, right?
Okay, yeah, because we should have at least K number of tosses to get at least K heads.
Yeah. So based on this, Andrew sir has derived the formula for that. So we could go through that. Okay. So this is just like combining the Poisson distribution with respect to the coin toss, okay, the binomial distribution one. I hope this much is like sufficient to solve the problem. If it is like anything else extra is required, I will discuss it. Okay, there.
What would lambda represent in this case? Your case, this tosses one.
What? Can I
in
repeat?
your example, what would lambda represent?
Lambda, it's a parameter for this Poisson distribution.
No, this is fine. But like in your case, the example you took, that you would have I tosses and then you would have K heads.
Yeah. Here I did
having K out of I, that is binomial. But for having I tosses, you've taken the Poisson distribution. What would lambda represent? The average number of tosses?
No. Lambda is not the average number of tosses.
Then what would it be?
It is going to be the 1 by. It is actually going to be the 1 by lambda is going to be the mean, I guess. So it's not going to be the average number of tosses. Okay.
It's the inverse of that.
Yeah, it's going to be. Wait 1 second. Let's get the slides. Yeah, this lambda, it's not going to be the mean. Okay. It is just going to be the parameter for this Poisson distribution. Okay. I'll check for the mean for the Poisson distribution. Okay. As far as I know, it's going to be 1 by lambda. It's not going to be lambda.
Yes.
Sir, can you take the slide one slide back? I mean, one slide back. So just 23rd number slide, sir.
Which one?
Yeah, this one, sir. I mean, where it is actually explained clearly what's lambda. I mean.
Can you repeat?
No,
Here
no,
we are
I'm
doing.
I was just checking whether they have explained the lambda completely or
No,
not.
no,
I mean,
it was
the
not
brief
seen.
explanation of it.
But
Okay, okay.
I'll be talking. I mean, I'll find out about that and I'll discuss that later. Okay.
Okay, sir. Okay.
Fine. So look at this problem. The number of customers arriving at shopping center in a 1 hour interval is a Poisson distribution. Okay. Is Poisson of 20, which basically means lambda is equals to 20. Assuming the probability that a customer making purchase is 0.4. The probability for success is 0.4 in a binomial distribution. It is similar to the tossing a coin one. Okay. Under the choice of the purchase of customers is independent. Let x be the number of customers who are making a purchase. Identify the range of x given n equals to n. Okay. Which basically means here when we have like n customers have arrived, when we have like n equals to n, small n, what does that say? The number of customers that has arrived is n, right? Correct?
Which n?
When you have n customers that has arrived, what is the range of going to be? What is going to be the range of x? First of all, range is going to be the number of customers who are making purchase.
Yes.
The number of customers who are making purchase could be 0, 1, 2, 3, and so on n. It can't be more than n because the number
20.
of customers that came is only n, right?
Yes.
I have a doubt, sir.
Yeah.
Sir, like here the lambda is 20. So can we say the lambda here 20 means the average number of people arriving in 1 hour?
No. See, the number of people arriving, it follows a Poisson distribution with the lambda value of 20. Okay. So that doesn't mean that there are only exactly 20 people arriving. The number of people arriving, it could be 0, 1, 2, 3, and so on.
No. I mean the average number of customers arriving in 1 hour.
Yeah, I have talked about this. The average value, I'm not entirely sure of this formula. Okay, for this Poisson distribution, it is either lambda directly or like 1 by lambda. Okay, so I check that.
In the 4 graphs that they showed, in that they showed that when lambda moves, then the average moves somewhat equal to the value of lambda, something like that. Yeah, when lambda is close to 0, average is that average, the maximum.
Okay. Yeah, right then. So yes, so the lambda is going to be good then, I suppose.
It's average or max, I don't know.
Yeah. So then I suppose the lambda is going to be the average number of people arriving. Okay, but then I'll confirm it later. Okay.
No, sir. So it's a peak only. We can't think about it as average.
Can you repeat, please? Instead of.
So it's a peak. So we can't think it as an average, I think.
See, if we do we cannot exactly say, but then what I'm saying is it is more likely that lambda will also be equal to mean, I'm saying. Okay. Anyway, I'll confirm this in a minute. Okay. So first, let's just solve this problem. Okay, and this does not depend upon whether you think 20 is mean or not. Okay. So it doesn't matter. For this particular first problem, when you have n equals to n, that is when you have the condition that the number of customers that has arrived is small n, right? So the number of purchases that could happen is, it could be from 0 to small n only, right? It cannot be more than n. So the correct option is, the range for this is going to be option 3. Okay. The option number 1 is not correct because the number of purchases could be 0 also. Okay. So identify the distribution of x given n equals to n. The distribution of x given n equals to n, that's going to be obviously Bernoulli distribution. Okay, because when we have this, let's use this. So we have this as a joint, right? We have this as the joint probability, right? When you have the condition with respect to given x equals to I, right? Then we'll be basically dividing with respect to the probability of x equals to I, right? And then this Poisson value equal minus lambda power I by I factorial, that gets cancelled out. So we'll be left out with this with this Bernoulli distribution probability. Okay. Or else normally itself we could just think of it like when we have this n equals to n, what does that say? The number of customers that has arrived is equals to n, right? When you have n customers that has arrived, what is the probability that some number of customers will make a purchase, right? Given that the probability of customer purchase 0.4, that's nothing but Bernoulli, right? This is similar to saying that I have tossed n coins. Okay, what is the probability that
Sir,
what is the distribution of like hits occurring? That's going to be Bernoulli.
I want to clear one thing. Like I have just googled it about the lambda and find out means the mean number of events happening in the event. I mean, like if n is taking n value, it means the number of people arriving in that 1 hour. But like if we make a slot of 1 hour in 24 hours each, and then what is the value, the average number of times 20 people are arriving in 1 hour, the average events, I mean the mean of the events. Like if
Yeah,
n is taking,
lambda is nothing but mean you're saying.
yeah sir, but I
The
mean the
parameter
mean
Poisson
event,
distribution lambda is going to be mean you're saying. Okay.
yeah, mean of the event, I mean how many times n number is happening, that average.
Okay, fine. Like it is, I mean, what does that basically means is like it's the average, it is the average number of people that arrives in like one hour interval.
Like if we make a slot of 1 hour in 24 hours, then how many times 20 people are arriving in all the 24-hour slots, 21-hour slots, 24 slots, the minimum is 20. I mean the average number of times 20 people are arriving.
Yeah,
Like that.
got it. So like it is like it is nothing but the mean. Okay, the lambda is nothing but the mean. That's what you're trying to say. Okay. So the second one, right? X given n equals to n. Here we are basically fixing the number of customers that are arrived. Once we have fixed the number of customers that are arrived, the distribution for x now, it's going to be equals to Bernoulli, obviously. So it's going to be x given n equals 10. It's going to be Bernoulli with the probability of 0.4. Okay, since the probability of success making the purchase 0.4, and then x is the number of customers who are making a purchase. It's not making a purchase. So x given n equals 10, it's going to be 0.4. It's not going to be 0.6. The question has been x is the number of customers who are not making a purchase, then it would have been 0.6. Okay, this is clear.
Sir, could you go back to your work?
Why we have not taken up the last option?
This one?
I believe it should be binomial. I believe that.
Okay, yeah, correct. Sorry, yeah. It's given, yeah, it's going to be binomial with the, yeah, right. It's going to be binomial with the probability of success of like 0.4. Yeah.
Yeah, total n number of people are arriving and probability of success is 0.4. I mean, I guess.
Yeah, the laptop is correct. Yeah.
Sir, could you go back to your workings, please? Sir, could you go to your notes?
Yeah, this one, right?
Sir, this is a joint probability, yeah? The Poisson multiplier.
Yeah. This is going to be the joint probability.
Okay, and the Poisson gives you the probability that there would be n customers, small n customers, and the binomial will say, okay, given that there are small n customers, then how many of them would make the purchase, right?
Correct. So given that there are like n customers that is arrived, what is the probability that like some customers have made the purchase? That is going to be the y given x equals to y. Okay.
Thank you.
Yeah. Okay. So they're asking for this. Choose the correct options for the values taken by the joint distribution. Fn(x) of 10, 2, which means the number of customers that are added is 10, and then the number of purchases that were made is 2. It's going to be e power minus 20. Okay, let's just compute this. this is going to be e power minus lambda power I divided by I factorial to this ICK, it's going to be nothing but I factorial divided by K factorial into I minus K factorial e power minus period. These two are going to get cancelled out. So it's going to be 10 comma 2, it's going to be e power minus 20 into 20 power 10, correct? Divided by K factorial into K is going to be 2 here. 2 factorial into 10 minus 2 factorial, correct? 0.4 power 2, correct? P power K. K is 2 here. Into 0.6, 1 minus P is 0.6 power 8. So first option is correct. The first option is correct.
So here it means that 10 people are purchasing and 2 people are not purchasing.
No, it's like 2 people are purchasing.
Oh,
Point
total-
4 is the probability for purchase, right?
Yes, yes.
X represents the number of people purchased. So 2 people are purchasing and 8 people are not purchasing. Okay.
It's like
And this-
the
okay.
10 people are arriving and 2 of them are making a purchase.
Yeah, this 10 represents the number of people arriving. Okay, and then 2 represents the number of purchases. Third option is wrong. I mean, third option is correct. This probably is going to be 0 because when 10 people have arrived, there is no way that there are going to be 12 purchases, right? Because each customer you can make at max 1 purchase. So this third one is correct. Okay, third option is correct. The probability is 0. Fnx of 10 comma 12, it's not going to do this. So obviously both of this wrong. Find the distribution of x.
Sir, this question is literally, sir. This question I had done it many times, but it doesn't happen to me. How to solve this question, sir?
Can you repeat?
Sir, I tried many times to solve this question. Can you just try to solve this as well?
Fourth question.
Yes, sir.
Okay, the fourth question, when they're asking for the distribution of x, what does that say is we need to find the marginal value. Okay, so instead of using this x and y, now I will use the same value n and x. Okay, so n equals to small n comma capital X equals to small x. Okay, this is a joint one. So it's going to be e power minus lambda into lambda power n divided by n factorial into nc x to p power x multiplied by 1 minus p power n minus x, right? This is a joint probability. Now if you are going for the marginal one, okay, for you to get the distribution of x, you need to get the marginal one. So notice we want this, right? We want this. Okay, so we should be summing over with respect to n. Okay, small n belongs to Tn of this. Okay, this will give you the, I mean, summing over the entire possible values of n. It gives you the distribution of this. I mean, it kind of gives you the distribution, the marginal distribution for the x variable. Okay, this is how we have used the marginal distribution formula. I just written the formula, nothing great there. So when we do this, when we're doing the summing over with respect to n, okay, e power minus lambda power n divided by n factorial to this n factorial divided by x factorial into n minus x factorial into p power x 1 minus p power n minus x. Okay. So this actually summing over with respect to n, this actually professor has done it. Okay, and it's going to give you something like lambda by 2, I suppose. Okay, it's going to give you like the Poisson distribution only with the value of like lambda by p, I suppose. Correct? Lambda by p or lambda into p. Yeah, lambda into p. Okay. It's going to be Poisson distribution with the lambda value of like lambda p. Okay. If you want me to go to that slide, I'll have to go to the slide.
Yes, sir. It's lambda into p.
Like the derivation for that, right? The derivation for that, it's
Yes.
going to be very lengthy one. That is why I want to.
Yes, the professor did that.
Yeah. Professor has done that. Professor has found out the distribution for x. So, but then he did not generalize it. He just found it with respect to the one for this for the success of half. I mean, p equals to half. He has done it. Yeah, here you could see fx of k. It's going to be e power minus lambda by 2 to lambda by 2 power k divided by k factorial. Okay, this has become a Poisson distribution with a lambda value of lambda by 2. Okay. All right. So we just replace this 1 by 2 with respect to p, right? Okay. With p, okay, you'll get the generalized formula. Okay. So which gives you here in a particular case p equals to 0.4 and then lambda equals to 20. So the distribution for x, right? It's going to be Poisson with the lambda value of 20 into 0.4. 20 into 0.4 is what? 8, right? Yeah. So we'll get this 8. Okay. Clear?
Which slides were those? Which week 0 or week 1? Week 1.
This one, yeah. This one it was
Which
mentioned.
lecture would it be in? That the derivation of this?
The derivation of this it's there in lecture 1.4.
1.4.
Lecture 1.4.
4. Okay, yeah. So we can get it from 1.4.
Okay, so now we have this x is uniform.
Will you please solve it against the question number 4? How it means
solve it for the derivation?
No. The solution for question 4, not the derivation.
Solution for question 4.
Yes.
Yeah, the same thing, right? You could see here the probability, right? This probability for fx of k, it's going to be e power minus lambda by 2 into lambda by 2 power k by k factorial, right? The 1 by 2 is the probability for success here, right? I mean, here, sir has taken a fair coin. Okay, instead of it's not a fair coin. I mean, it's not a fair purchase. So the probability of success is p, right? So instead of 1 by 2, you could replace 1 by 2 with p. Okay, so it gives you e power minus lambda p. Actually, it's like that p is the generalized case. Here, sir has taken a special case of p equals to half. Okay. Clear? Like yes. that half, that instead of half, you could think of it as like p. Okay. So it's going to be e power minus lambda p into lambda p power k by k factorial. Okay. So in a particular problem, lambda is 20, p is 0.4, so you'll get a Poisson distribution of like 8. Clear?
Yes, sir.
So we have this for the question number 5 and 6. Before we move ahead, we'll take like 5 minutes break and then we'll continue. Is that okay?
Sir, can we change the timings of these lectures?
Timings of the session, yeah, we'll discuss that. Like whatever questions you have, the generalized questions, right? If you post it in discourse, then someone is always going to be answerable for that. Okay, instead of asking me verbally over here, you could post it on discourse. Okay, so that we'll be following up there. All right. Yeah, yes. We'll take 5 minutes break and then we'll continue the session later. Okay. Thanks. All right. So let us continue. Where we are left.
Yes, sir. Yeah.
See, X is a uniform distribution. The values it could take is 1, 2. Y is a number of races obtained from a deck of well shuffled 52 cards in extras. Okay. So the number of draws depends upon the output here. So choose the correct statements in the following. Range of y given x equals to 2. Okay. Y is the number of races. So when we are doing like 2 draws, so the number of races that are taken, it could be 0, 1, 2. So the range of y given x equals to 2 is 0, 1, 2. That's correct. The range of y given x equals to 1 is it's going to be 0, 1. When you're making only one draw, so that draw it could either be ace or it might not be ace. There's no possible way that you get 2 aces, right? When you're doing only one draw. So second option is wrong. Third option is y given x equals to 1 is a binomial with a binomial distribution with n equals to 1 and the probability is 1 by 13. That's correct. Okay, so because when you have this when you're drawing like one card, right? Okay, when you're drawing one card, so the probability that you get ace is going to be nothing but this 4c1, right? I mean, it's going to be equals to 4 by 52, right? Which is going to be 1 by 13. Okay, so it is going to be the binomial distribution, okay, of n equals to 1 and 1 by 13. Y given x equals to 2, it's not going to be the distribution. It's not going to be binomial of 1, 1 by 13. It should have been the binomial of 2, 1 by 13. So that's why option number 2 is wrong. Sorry, option number 4 is wrong. All right, is this clear? When you have mentioned that there are 2 cards that are drawn, right? When you have 2 cards that are drawn, in the distribution it's going to be a binomial with the value of n as 2, right? It won't be 1 by 13. Correct? Am I clear on this? Hello. Am I clear?
Yes, sir.
Yes, sir. Yes. Yes, sir. Got it, sir.
So they are asking for the identify the joint PMF of x and y. Okay. So let's just solve for this. Then we have y is going x is going to be the number of draws, right? Number of draws, it could either be 1, 2. So y is going to be this number of races. The number of races, it could either be 0, 1, 2, right? Okay, so what is going to be the probability for this x equals to 1? It's going to be half, right? Because it's a uniform distribution. All right. I'm going to calculate for this 1, 1. It's going to be half for the probability of x equals to 1. Probability of let me calculate. Y equals 0. That ace is not drawn, right? We have 52 cards. Among those 52 cards, we have 4 cards which are ace. Okay, we have like 52 cards. Among those 4 cards are ace. What is the probability that the card drawn is not ace? It's going to be 48 divided by 52, right? Okay, so pxy of 1, 0, it's going to be 1 by 2 multiplied by 48 by 52. And then pxy of 1, 1, it's going to be 1 by 2 multiplied by 4 by 52. Because when you're drawing like one card, what is the probability that it's going to be ace? There are like 4c1 divided by 52c1. Directly I have written as like 4 by 52. Okay. And then pxy of 1, 2, it's going to be 0 because when you're drawing when you're drawing one card, there is no way that you're going to get two aces, right? So this is going to be 0, it's going to be 12 by 13, right? Am I correct here? 13. Yeah. Correct. So this is going to be 6 by 13. Okay. It's going to be 6 by 13. 1 comma 1, it's going to be by 26. It's going to be 1 by 26. Okay, similarly for x equals to 2, pxy of 2 comma 0, it's going to be 1 by 2. Probability for x equals to 1 is going to be 1 by 2 multiplied by what is the probability that you get 2 aces when you're trying like 2 cards? Sorry, 0 aces when you're trying 2 cards. It's going to be 48 C2 divided by 52 C2. Okay. Similarly for 2 comma 1, it's going to be half multiplied by 48 C1 multiplied by 4C1 divided by 52 C2. And similarly for 2 comma 2, it's going to be 48 C2 divided by 52 C2. Okay, we just substitute the values, you'll be getting the answer. Okay, I'm not going to solve for this. That is, I'm not going to exactly solve for this. But then
So why was it multiplied by half? Sorry, sir.
What?
Multiplying by half. Sir. Sorry, I missed that.
Multiplying by half
into every probability we have started by half into something.
Yeah. Because that is a probability for x we need to have, right? Probability for x equals 1 multiplied by probability for y equals 0. Sorry. Okay, wait. When you're solving for this pxy of 1 comma 0, okay, what we could do is we could solve for this going to be nothing but p of x equals 1 multiplied by p of y equals 0. Okay, p of y given x equals to 1, right? This is nothing but this, right? P of x equals to 1 is nothing but half, and then when x equals to 1, what is the probability that you get 0 aces? It's going to be 48 by 52. Okay. Similarly, pxy
So, but why, I'm missing y probability of x is equal to 1 is half, sir. What is x?
Okay.
I'm missing. Understand that.
They have mentioned that x is a uniform distribution. X is a uniform distribution of 1 comma 2, right? So that is why probability for x equals to 1 is half, probability for x equals to 2 is also half.
Okay, sir. Sorry, I missed this. Yeah, thanks.
Okay, so actually just by looking at this p of this 1 comma 0, we can get the answer, because the answer which you got 6 by 13 is here only option number 3. Okay, there's no other option where you got the answer. All right, fine. 1.4 is done. Okay, question number 6 is clear, right? I didn't entirely solve it, but then I just wrote down the values. Okay, you just need to substitute those and then you get the answer. All right, go to activity question 1.5. Now we have this is going to be more than 2 discrete random variables. Okay, until now we looked at only 2 random variables. From now onward it's going to be more than 2, but the idea is going to be the same. Okay, it's not going to be anything different. Okay, like while solving problems, I'll note down the formula, so from there it's going to be clear. Like even in the multiple random variables, the concept is going to be the same. A fair coin is tossed 4 times. Let x denote the number of hits on the first toss, y denote the number of hits on first 2 tosses, z denote the number of hits on It's in the first four tosses. Fair coin is tossed 4 times. Okay. So what they're saying is they're saying find XYZ of 0, 1, 2.
Sir, I have a doubt, sir. Basically, when to decide that there will be two combinations, means we will be using the uniform as well as the binomial together as we have solved the question in 1.4 activities. Means both the concept together.
How do you know that you are asking?
Yes, sir. How do we know?
Because they have mentioned here, right? See, generally, when you have this, see, this is a joint distribution, right? This is joint distribution, and they mentioned this x follows a uniform distribution, and this y follows this binomial one. Okay, y follows the binomial one. So based on that, like whenever we need to get this particular value of p of x equals to 1, then we'll use then we will use this that okay, we know that x is an uniform distribution, so it's going to be half. Okay, only then you will use it. The basic formulas are going to be the same. Okay, but to get the probabilities only you'll use this uniform uniform distribution and then this binomial distribution. Okay.
Okay. So and in such cases, all the independent cases will be there only.
Yeah. Here, these are not exactly independent, right? Because as you could see here, I have written this, right? P of pxy of 1, 0 is going to be p of x equals to 1. I did this p of y given x equals to 1. Okay. Y given x equals to 1 of 0. Okay. These are not independent.
Yes, sir.
Okay. Maybe the way I wrote it, like since I wrote it like multiplication of two numbers, it could appear as like independent, but then I wrote this for one only. Like this 48 by 52, 48 by 52 came because I'm taking one draw, and among that one draw, when I mention like I'm taking one draw, that has become a condition, right? This one, y given x equals to 1. Y given x equals to 1, there's nothing but what is the probability that y equals 0 given x equals to 1? It's going to be 48 by 52. Probability of y equals 0 is not always 48 by 52. Okay.
Okay, sir.
Clear on this? It's not independent.
Yes, sir.
It is actually what I have written here is 48 by 52, this 4 by 52, 48 C2 by 52 C2. That is a conditional probability one. Okay.
Yes, sir.
Yeah.
Means basically what I was thinking that both the two cases, that is, for example, in the case uniform versus binomial, both together will be independent.
No, that need not always be the case. Actually, if you just check this now, and then if you just check this, and then what I told, right, that p of pxy of 1, 0 is going to be px. Okay. Once you computed this this joint probability, right, and then if you computed the individual marginal probabilities, that is p of x equals to 1 and then like p of y equals 0. Okay.
Yes, sir.
Then if they both are equal for all the values of x comma y, then you could say that they are going to be independent. But I don't think here it's going to be independent. They are going to be dependent.
Okay. Yes, sir. Yes, I think the second point, 2.1, week 2.1 will be dedicated to this topic, independent or not independent, because I would have watched today. Okay. Thank you, sir.
Where are we? Okay, we are at just 1.5. So fair coin is tossed 4 times. Let x denote the number of hits, y denote the number of hits in first toss, y denote number of hits in first 2 tosses, z denote the number of hits in first 4 tosses. They are asking for x, y, z 0, 1, 2. Okay. Right. Fx, y, z of 0, 1, 2, right? Okay, the way I'll write it is, I'll write using this probability of this conditional one. Okay, first I'll write probability of x equals 0 multiplied by probability of y given x equals to 0, okay, of 1 multiplied by probability of z given x equals 0 and y equals to 1. Is this all right? Is this formula all right for you to understand this?
Yes, sir.
Yes, sir.
Okay. And this x equals 0, x equals 0 is nothing but the first toss, right? In the first toss, what is the probability that you not get head? Half, right? Let me check if it is a fair coin or not. Yeah, it is a fair coin. So probability for x equals 0 is going to be half, right? In the first toss, the probability for it to get ahead or not get ahead, it's going to be same. So p of x equals 0 is going to be half. Okay. And then the probability for y equals to 1, given that x equals 0. What is y? Y is number of heads in two tosses. In the first tosses. Okay. Already we mentioned that in the first toss, when you mention that x equals 0, what does that mean? First toss we did not get ahead. Okay. First toss we did not get ahead. And then we are saying y equals to 1. Okay. For us to get y equals to 1, when x equals 0, what does that say? The second toss should definitely be ahead, right? Correct? Alright?
Yes.
Of this. Hello.
Yes.
Correct. So what is that probability? It's going to be equals to half. Okay. Clear on this? Oh.
Yes, sir.
How you got half? Okay. And then let's go to the later part. That is probability for z equals to 2, given that x equals 0 and then y equals to 1. Okay. Which basically means now for us the first two tosses outcome are fixed. Okay. The first toss is like tail because it should not be head, and then the second toss is head. Okay. And then over the remaining two tosses, you should be getting z equals to 2. Already you got one head here. So which basically means over the next two tosses you should get one head, right? Correct? Over the next two tosses, if you get one head, then the total z value is going to be equal to 2. Because z is going to be number of tosses, number of hits in the first four tosses. Okay. Already since we got head in the second toss, you should be getting only one head in the next two tosses. That is the third and fourth tosses. What is the probability that you get exactly one head in the next two tosses? Can someone tell me? Could either be tail head or head tail, right?
Yes, sir.
Am I correct on this?
Yes, sir.
So it's going to be 2 divided by 4. The total possible scenarios for this is going to be it's going to be 4, and among those 4 possible cases there are like two cases like tail head and head tail. So it's going to be 2 by 4. 2 by 4, it's again going to be 1 by 2. The total value is going to be 1 by 8. Okay.
Yes, sir.
Is clear?
Yes, sir.
Yes, sir.
So now we have this 1 by 8. What is the probability for x, y, z of 0, 1, 4? Okay, this is going to be easier. Okay. When we having this like x, y, z of 0, 1, 4, you are saying in the first toss you not get head. In the first two tosses you get one head. Okay. In the first 4 tosses you get 4 heads. When you're getting in the first 2 tosses 1 head, there is no way you're going to get in the first 4 tosses 4 heads, right?
Yes.
Max you could only get is 3. Okay. So probability for 0, 1, 4, it's going to be 0. Am I clear?
Yes, sir.
So now we'll come for this 1, 1, 3. Okay. Again, we will use the same one, this conditional one. Okay. So probability for x equals to here, since it is like 1, 1, 3, it's going to be probability for x equals to 1 multiplied by probability of y given x equals to 1 of like 1 multiplied by z given x equals to 1 comma y equals to 1. Okay. Probability for x equals to 1 is half. That is in the first toss, the probability that you get that you get a head is half, right? Since it's a fair coin. And they're saying in the first two tosses, you should get only one head. Okay. If you're supposed to get only one head, right? And since you already got head in the first toss, it basically means you should be getting tail in the next toss. Okay. So it's going to be half. Okay. The probability that you get tail in the next toss is second toss half. The later one is x equals to 1, y equals to 1, and then z should be equals to 3. Z, what is Z? Z is the number of tosses in the first 4 tosses. Number of hits in the first 4 tosses. Okay. And you already got one head in the first 2 tosses. Okay. You only got one head in the first 2 tosses. So in the remaining 2 tosses, you should be getting head definitely. Okay. There is no other way. The only way that could happen is 1 by 2 into 1 by 2. It's going to be 1 by 16. Okay. So this could only happen. This 1, 1, 3 could only happen if it has an head, tail, head. Okay. Only in this particular scenario, you have x equals to 1, y equals to 1, and then z equals to 3. Okay. And you know that the probability for us to get head, tail, head is going to be 1 by 16, right? So this is going to be 1 by 16. Okay. Yeah, I done it correctly. All right. Until now, is it clear?
Yes, sir.
Okay, yeah. Let's move on to the next one. This is going to be the marginal value which I have discussed, the marginal distribution formula which I have discussed, right? Before we summed it over the unwanted variable of, like, suppose if you want to get this x1 of t1, right? You just summed it over x2. Okay. But let's say like we have the x3 also, then we need to sum it over with respect to x3 also. Okay. Clear? Like imagine it like I don't want to complicate this. No. We just need to sum it over like all the unwanted variables one. Okay, very random variables. So since you want the marginal distribution of like fx1, okay, so we should sum it over all the values of this t2 and then t3. So the first option is correct. Okay, fx1 x2 of this t1 comma t2. So here they're asking for the joint distribution of t1 t2. Sorry, joint distribution of x1 x2. Okay, so here what is the unwanted variable for us here? It is going to be t3. It's going to be t3, right? So you need to be summing it over all the possible values of t3. So that is why option number 2 is also correct. Okay. Now if you look at it, option number three, you can't be summing it over like t1 comma t2. Okay. So option number 3 is incorrect. Option number 4, fx2 of t2 is going to be t2 belongs to x2. fx2 of t2, it should have been sum over t1 belongs to tx1 and t3 belongs to tx3. We should be summing over t1 and t3, not over t2. So option number 4 is wrong. All right.
Yes.
Is this clear? My explanation for this first question?
Yes, sir. Yes, sir.
Yeah. So we'll move on to this second problem. We have here 3 random variables. Okay, this joint PMF is given. You could check for this even here the sum of the joint PMF, right? It should be equals to 1. Okay. And here, can someone tell me? I'll be finding this fx1 of x2, right? Okay. The joint distribution of this x1, x2, right? Do you think that some of the probabilities of x1, x2, right? The sum of the probabilities of x1, x2, will it be equals to 1 or not? Did I?
So will you please repeat the
Is my
question?
question clear?
No, sir. So will you please repeat it again?
Okay. So what I was saying is, we have here fx1, x2, x3, right? Of t1 comma you have here t1 comma t2 comma t3, right? Right. We know that sum over all the values of all the values of this t1 belongs to tx1, t2 belongs to tx2.
It's equal to 1.
Yeah, t3 belongs to tx3. It's going to be equals to 1, right? So I'm asking, what about this? What about this? And what about this? What about this on this?
So I think it should be the 1 minus fx1 x2 x3. T will remain and the t dash 2 and t dash 3.
Okay, think about it again.
So the means we will get in parentheses we will have t dash t dash 2 and t dash.
Okay. For a moment, forget about this. What about this?
Not equal to 1.
Huh? This is going to be 1.
Not equal to 1.
It's not equals to 1. Okay,
Yes, sir.
why is that? It's going to be equals to 1, right? What is fx1 of t1? Can someone tell me? fx1 of t1 is nothing but
One of the values that
fx1, fx2, fx3 of sum over with respect to t2 belongs to tx2 and then t3 belongs to tx3, right? This entire sum this fx1 is nothing but this value, no?
But T1 will remain constant, no, sir? T1 will remain constant, no?
Wait. Yeah, T1 will remain constant there.
So it will not be equal to 1.
Yeah, correct. No, not exactly correct. But this is what now. But what about this value? This is nothing but sum over T2 belongs to Tx2, comma T3 belongs to Tx3 of fx1, T1, comma T2, comma T3, right? This is the value of fx1 of T1 is this value, right? And this I'm summing it over with respect to T1 belongs to Tx1. Okay. This is nothing but this one, no? Right? So this is going to be equals to 1. Okay. This is not equals to 1. Not equals to 1 is not correct. It's going to be equals to 1. Similarly, even this is going to be equals to 1. Okay. Some of the marginal probabilities, right? It's going to be equals to 1 now. You have seen it, right? In the joint PMF of two variables. Px1 of x, it's going to be equals to 1. Sum over the probabilities. So similarly, Here also it's going to be equals to 1. Okay, think about it.
Are we saying that fx1, x2, t1, t2 is the marginal probability of x1?
You see, yes, fx1 of t1 is nothing but the marginal probability of x1, right?
Yes.
Marginal probability of x1, and then we know that sum of the marginal probabilities of any random variable, it should be equals to 1.
Yes.
So sum over of t1 belongs to tx1 of fx1 of t1.
Yeah, it's the sum of all the marginal probabilities.
Yeah.
Yeah.
So
And
even here
fx1
also
t1 is the sum of the marginal probabilities of the other two variables.
Oh, can
What are they? The marginal probability of x1 would be the summation of t2, the summation over t2 and t3.
Correct.
That is the joint probabilities of t2 and t3.
This for a particular t1, it is going to be the exact joint probability of t2 and then t3 summation. Okay.
It's sort of like if we say that x1 is given, it's conditional on x1 being t1, right? The joint probability of t2 and t3, given that.
No, this is not exactly conditional. It is like summation over all the cases where you're having x1 equal to t1. Summation over all the cases. Okay, like
where x1 is t1. Okay.
Yeah. You're summating over all the cases where x1 is t1. Okay.
Oh.
For you to do that, you're just doing it for all the possible values of t2 and t3, right? Where x1 is t1.
Yeah.
Okay. This is nothing but, and once you're done with this, once you're done with finding our fx1 of t1, now we are summing it over with respect to t1 also, which is nothing but
marginal probability.
Yeah. It is nothing but you are doing the summation over all the joint probabilities, right?
Yeah.
So it's going to be equals to 1. So even this is also going to be equals to 1, because I could write this fx1 of fx1 fx2 as sum over of t3, right? Correct.
Sorry.
I don't want to. Huh?
Could you repeat that again? What did you say?
So this fx1 of t1 is nothing but summation over t2 and t3, right? What is fx1, fx2? fx1, fx2 is nothing but summation over t3, no?
Yes, sir.
Summation over t3, right?
Yes, sir.
Yeah.
So tx1, t2 belongs to tx2 of fx1, fx2 of t1, t2, right? This is what we need to find. But what about this value? This is nothing but summation over t3 belongs to tx3 of fx1, x2, x3 of t1, t2, t3, right? So basically you're summing over x1, x2, x3 or. So even here sum is going to be equals to 1. Okay. Enough. And now we'll go to normal problems. Okay. So this option number 4 is incorrect. It should have been like summation over t1 and t3. Okay. That is summation over tx1 and tx3. Now we'll come to this problem. Okay. The whatever I have told here, right? whatever I have told here, that this is summation over the joint probabilities of x1, x2, it's going to be equals to 1. You can see this here via this example. Here, the sum over of this 1 by 6 plus 1 by 6 plus and so on, it's equals to 1 now. Okay, that is summation over this fx1, fx2, x1, x2, x3 is equals to 1. Now we'll come for this x1, x2, joint prime of x1, x2. How do you compute this joint prime of x1, x2? You need to sum over all the possible values of x3, right? Correct? For 0, 0, okay. For 0, 0, what do we have? Okay, x1 equals 0 and x2 equals 0. You're getting here. Okay, you're only getting it here. So it's going to be equals to 1 by 6. Okay, it's going to be equals to 1 by 6. And what about 0, 1? 0, 1 is going to be over here, 1 by 6. 0, 1 is going to be over here too, 1 by 6 plus 1 by 6, 2 by 6. 0, 1 is going to be 2 by 6, 1 by 3. Okay. And what about 1, 0? 1, 0 is going to be this plus this, 1 by 6 plus 1 by 6. It's going to be again 2 by 6.
I'm sorry, sir, I can't understand what you're doing.
You're not able to understand this?
No.
Okay. This one. X1 we have, X2 we have, X3 we have, 0, 0, 0, and then 0, 1, 0, I guess. Can someone tell me these values? Please, no? 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1, 0.
Yes, sir. I'll
0, 1, 1. It's going to be 1 by 6.
1 0 0.
1 0 0 is 1 by 6.
1 0 1.
1 0 1 is 1 by 6.
And then 1 1 1.
Okay. So for us to get the joint probability of x1, x2 of 0, 0, what is it? It is summation over all the possible values of fx1 of fx1 x2 of 0, 0 is going to be summation over all the values of x3 of x1, x2, x3 of T1, T2, T3, right? Basically, you should be summing it over all the possible values of Tx3, right? Correct?
Where x1 and x2 are 0, 0,
yeah,
right?
Yeah. So basically, where do you have this x1 and x2 as 0? Here now.
Only, yeah.
Only here you have.
Yes.
So the probability for fx1 x2 of 0, 0 is 1 by 6.
Yes.
Okay. Later for the 0, 1, where do you have? You have it only here.
Yes.
Okay. So it's going to be 1 by 6 plus 1 by 6.
Yes.
1 by 3. Okay. So 0, 1 is going to be 1 by 3. Similarly, for 1, 0, 1, 0, you have it only here. Okay. So it's going to be 1 by 6 plus 1 by 6, 1 by 3. Okay.
Okay.
And then for 1, 1, it's going to be 1 by 6. Since you have it only here. Okay.
Okay.
Now, if we sum it over this, that is 1 by 3 plus 1 by 3 plus 1 by 6.
1.
What is it?
Yeah, it's 1.
Right? 1.
No.
Okay, 0, 0 also we got. That is also 1 by 6.
Yeah.
So 1 by 6 plus 1 by 3 plus 1 by 3 plus 1 by 6. That's going to be equals to 1. Okay.
Yes.
Is this clear?
Yes, sir.
That is what I meant when I said this.
Yeah,
When I said this
fx1 x.
Okay, so here in our particular case, correct option is option 4. Okay. 1 second. Okay, so by solving this, what we get is this is the correct answer. Find the joint PMF of x2, x3. So x2, x3 is x2, x3. It took 0, 0 in 2 cases. X2, x3, right? It took 0, 0 in 2 cases. So for this, of 0, 0 is 1 by 6 plus 1 by 6, 1 by 3. Okay, because he took here and then here. Okay, so these two, and then 0, 1 it took only here.
1. Yeah.
Okay, yeah. So 0, 1 is going to be 1 by 6, and then 1, 0 it has taken twice, I guess.
Once.
1, 0 only once. Yeah, 1, 0 only once. 1, 0 is going to be also 1 by 6, and then 1, 1
twice.
Yeah, 1, 1 here, and then 1, 1 here. Yeah, twice. So it's going to be 1 by 6 plus 1 by 3. 1 by 6, 1 by 3. So even here, if we sum it up, it's going to be equals to 1. Okay.
Yes.
So it should be, what it should be 1 by 3, 1 by 6, 1 by 6. Right. 1 by 3, 1 by 6, 1 by 6, 1 by 6. Yeah. Yeah. The option number 1 is correct. Check it. Okay, this we didn't select the option, that's why it's shown as wrong. Okay, but 1.6 is clear. Multiple random variables. If you see here, multiple random variables, it's not so much different from the 2 random variables. It's just that the number of variables has increased, the computation has increased. Okay, clear?
So when we are looking at the joint PMF, we're actually finding the marginal PMF of those two.
When you're looking for the joint PMF, you're actually finding the, yeah. You could actually, maybe it's not better to call it as like marginal PMF. You could call it as like joint PMF of 2 variables instead of 3 variables. Okay, because I guess when you the only way you could call it as marginal PMF is for individual variables, individual random variables. Okay, even if it has been like x1, x2, right? It will still be called as joint PMF. See, that's why they have mentioned it as like find the joint PMF of x2 and x3. Okay, but it's actually similar to the marginal one where we sum over the probabilities. Okay, clear? Clear on this? No? Hello? I guess it's clear. We'll come for this. The last one, conditioning with the multiple discrete random variables. This is, even here also, it's not going to be too much different from what we have seen before. It's just going to be, since we have more variables, we should be more cautious while we are writing this formulas. Okay. They mentioned x1, x2, x3, x4. Yeah, here we have 4 random variables. The joint PMF consists of 4 random variables. Okay. What is the correct option? tx1, tx2, tx3 is 0, 1. tx1 is 0, 1, tx2 is 0, 1, tx3 is also 0, 1. Yeah, it's correct. But for tx4, it's 0, 1, 2, 3, 4. Yeah, it is correct. First option is correct. tx1 is not 0, so the second option is not correct. Range of x1 given x2 equals 0 is 0. When x2 is given as 0, which basically means this t2 as a 0, right? And you have t2 as 0, right? There are 3 possible cases, and in those possible cases, of x2 as 0, what do you have for x1? We have here 0, and then we have here 1 also we have. Okay. Yes. So the range is not exactly 0. It's going to be 0 and 1. So that is why option number 3 is incorrect. Okay. All right. Is this clear?
Yes.
And then the range of x2 given x1 equals 0 and x3 equals to 1. We should check for both x1 equals 0 and x3 equals to 1. x1 has 0 and x3 equals to 1. This is 0, 0, so that's not the case. 0, 1, yeah, that is the one we are looking for. When you rank for 0, 1, when x1 takes 0 and x3 takes 1, x2 is taking 1, so the range will consist 1. Let's look if there are other cases. When x1 is taking 0, 1, we have 1. Yeah, there is no other way. Okay, so the range for this x2 given x1 equals 0 and x3 equals to 1 is going to be 1. Okay, it's clear, right?
Yes, sir.
Because when x1 equals 0 and x3 equals to 1, okay, x2 can only take 1 here. Okay. Okay. They're asking for calculate the value of fx1 of 1 given that x2 equals 0 and x4 equals 0. Okay. x2 is 0 and
x4 0.
Okay. x2 0 and x4 0, that has happened only in one case, right? x2 0 and x4 0, that has happened only in one case. Okay, and given that they're asking for x1 equals to 1. Okay, given that x2 equals 0 and x4 equals 0, there is no way you're getting x1 as 1. You could only get x1 as 0. Okay, so this is going to be 0. Clear?
Yes, sir.
They're asking now calculate probability for x3 equals to 1 and x4 equals to 1 given that x1 equals to 1 and x2 equals to 1. Okay. x1 x2 as 1. Okay. x1 x2 as 1, it occurred in this last 3 scenarios, right?
Yes.
Correct? In the last 3 scenarios, x1 is 1 and x2 is 1. And among those scenarios, in what all cases we had x3 as 1 and x4 as 1? In 2 cases. Correct?
Yes, sir.
So what is the probability for x3 equals to 1 and x4 equals to 1 given that x1 is 1 and x2 is 1? It's going to be 2 by 3, right? Are you with
2
me?
by 3. I didn't get this 2 by 3.
You didn't get the 2 by 3 part?
No, sir.
Okay. You know this probability for intersection and then the divided by the probability for this. That you know, right?
Yes, sir.
We'll use that and then get that spelling. Okay. Probability for x1 x3 equals to 1. Question is x3 is 1, x4 is 1, given that x1, x2 is 1. x3 is 1 and then x4 is 1, given that x3 is correct. Given that x2 is 1 and x1 is 1, right?
Yes.
So this is nothing but probability for x3 equals to 1, comma, x2 equals to 1, comma, x1 equals to 1, comma, x4 equals to 1 divided by probability for x2 equals to 1 and
x1 equals to 1.
x1 equals to 1, right?
Okay, joined by PML.
Yeah.
Marginal.
Yeah.
Mhm.
So remember this. And what is the probability for this intersection part? It's going to be 1 by 8 plus 1 by 8, right? 1, 1, 1, 1, 1, 1, 1, 1, it occurred 2 times.
Yes.
1 by 8 plus 1 by 8,
Okay.
right?
Yes.
And then what about this 1, 1 part? x1 equals 1 and x2 equals 1, it occurred 3 times. 1 by 8 plus 1 by 8 plus 1 by 8. All right.
Okay.
So this is going to be 2 by 8 divided by 3 by 8. It's going to be 2 by
That portion occurred 2 times and that one 3 times. Okay.
Yeah.
Out of it.
Okay. Now we'll come for this fourth problem. x1, x2, x3 is x1 of fx and x2, x3, where txi is 0, 1. Okay. For each I, txi is 0, 1. For each I, fx, if fx2, fx3, fx2 0, 1 is 1 by 5, fx3 of 0 is 2 by 5, fx2 of 0 is 2 by 3. Find the value of this one they have given. Okay, they are given some values and then they ask us to find the some value. Okay, so let's look at this. First of all, we need to find this, right? Okay, let us write down this. Okay, let us write down the formula for that, and then let us then try to use what was given, and then we'll try to get it. Okay,
x1 given, x2 equals to 0.
You need to find. We need to find x1 as 0, given that x2 0 and then x3 as 1.
0, 3, 1. Yes.
So our goal is to find x1, x2, x3, 0, 0, 1.
x2 and x3 are given. We have to find f of x1.
x2 is 0, comma, x3 is 1, right?
x1.
Okay, this is what we need to find, right? And this is going to be equals to, from our formula, it's going to be equals to fx1, fx2, fx3 of 0, 0, 1
upon x2, x3.
Yeah, upon x2, x3 of 0, 1, right?
Yes.
So let us see if they gave these values or not. Okay, they gave fx1, fx2, fx3, that was given directly, but then they did not give this value of fx2, fx23, they did not give, right? So for you to get this, this was already given. This was the numerator was given. We need to find the denominator. x2, x3 of
0, 1.
0, 1. We need to find. For you to get that, they gave fx3 and then x2 given x3 equals to 1 is 0. Of 0 is 2 by 3.
Is it something like if we can do the factors? There was some concept I think in the last lecture.
What?
Some factoring concept was there, means we can.
Yeah. We'll try to do. So this one, probability for x2 equals 0 given that x3 equals to 1 is 2 by 3, right? And then they are given that probability for x3, f of x3 is f of x3 equals to 0 is what they are given? They are given that as 1 by 5. Sorry, 2 by 5. Correct? fx3 of 0 is 2 by 5.
Yes.
X3. Fx3 of 0 is 2 by 5. And then they have also mentioned that x1, x2, x3, it only takes 0, 1, right? Correct?
Okay.
It could either take 0 or 1, correct?
Mm-hmm.
So when fx3 of 0 is 2 by 5, what about fx3 of 1? This, what about fx3 of 1? It's going to be 3 by 5, right?
I think I missed something.
Because fx3 of 0 plus fx3 of 1, it should be equals to 1, because x3 can take only 0.
Okay, only 0 and 1. Mm-hmm.
And fx3 of 0 is given as 2 by 5.
Okay,
which
1 minus
gives you
2
this as like 2 by 5. Yeah.
Mm-hmm.
Now using this, we can find the fx2, fx3. fx2, fx3 is nothing but x2 given, x3 equals to 1 of 0 multiplied by fx3 of 1, right? Correct?
Okay.
So it's going to be 2 by 3 multiplied by 3 by 5. 2 by 5. Okay. fx23 of 0, 1 is 2 by 5.
2 by 5.
So now that we know fx23, fx2, fx3 of like 0, 1, substituting it here, we'll get it as like, what is this numerator value? Numerator value is given as of 0, 0, 1 is given as
1 by 5.
1 by 5 divided by 2 by 5. So it's going to be 1 by 2. Okay. So it's going to be 1 by 2. Right. All right. Yeah. So yes, we have covered almost all the concepts we have covered. Okay. Activity questions we solved all. Okay.
Sir, I have a doubt, sir. In week 0, part 2.
Week 0, part 2.
Yes.
Okay, like it has already been like 10:48. The remaining questions and all we'll be discussing in the next
Sir,
batch.
only a single question. Sir, only a single question is there.
Okay, week 0, part 2, which one?
Geometric, sir, geometric. Yeah,
Question or
activity.
like
Yeah,
concept?
activity question, sir. Activity question.
Okay.
Question number 3. Question number 3. Yeah.
What is the
This
probability that
question.
Ronaldo will win?
Yeah, sir. This question I have tried many times, but didn't get the way to do it.
Okay. Football match between Argentina and Portugal is going on till the last minute. None of the teams has scored single goal, so that the match decided to go for penalty shoot. From Argentina, Messi will go for penalty all the time, and from Portugal, Ronaldo will go for penalty all the time. There is a 40% chance that Messi can convert penalty into a goal, whereas 70% chances Ronaldo can convert penalty into goal. Each shoot is like totally independent of the previous one. Okay. The two players will go for penalty shoot alternative, and Ronaldo will start the penalty. Ronaldo hits a penalty first, then the Portugal will win, and the Messi will not be allowed to do the penalty. Okay. So here for Ronaldo to win, right? Correct?
Yes.
For Ronaldo to win, let's take like R as like probability for success of like Ronaldo, right?
Yes, sir.
RP, right? It's given as what? 0.7.
0.7. Yeah.
Yeah. And then what do we say probability for Messi success? It's going to be what?
0.4.
Right? Yeah.
Yes, sir.
And then Ronaldo is going to start the penalty, right? So if the Ronaldo is success in the first chance itself, that is, if he scored goal in the first chance itself, then he will win, right?
Yes,
So
sir.
this one scenario plus let's say like he did not score penalty in the first scenario, right? What is the probability for that to happen? 0.3, right?
0.3, and then
Yeah. Then if the Ronaldo did not score, then Messi also should not score, right? Because if Messi scores, then Argentina will win.
Ronaldo will lose the match. Yeah.
Yeah. So Messi also should not score a goal. What is the probability that Messi will not score a goal?
0.6 though.
Yeah. So when these two did not score, right, in the first round, in the second round, if the Ronaldo scores, then they'll win, right? Correct?
Okay, yes.
And then let's say in the later one, first round they did not score, and second round also they did not score. What is the
So
probability?
it's like never ending, sir. It's like never ending series.
Yeah,
It will go and go and.
yeah. So now it's going to be 0.3, 0.6 whole square into 0.7 plus 0.3 into 0.6 whole cube.
3 into 0.7.
Plus 1.
Yes, sir.
This is geometric progression.
Sir, noise is coming. Can you please mute someone?
Okay. This is going to be geometric progression. A by 1 minus R. A is 0.7. R is going to be 1 minus 0.3 into 0.6. Okay.
Sir, this I didn't get. How did you do this? I'm lacking the concept of this question.
This one, right?
This is the last step. So
the last step. This is the
formula for GP, sir. Formula for geometry progression, sir.
Yeah. I know that. So just want to explain that. So probability for Ronaldo success now, it's going to be this plus this and so on, right?
Yeah.
It's 0.3 into 0.6. You consider that as R. Okay. It's 0.7. You consider that as A.
Okay.
This series is nothing but A plus
R into A square R
plus AR cube plus and so on. Okay. Where R is less than 1. Okay. So the sum over of all this, it's going to be equals to A by 1 minus R. Okay.
So this is geometric progression formula.
Yeah.
Is
Geometric
it?
progression, sum of like infinite values.
Okay, infinite series. Okay.
Yeah. Where R is less than 1. Yeah. A by 1 minus R will be there. So substituting value of A and then R, you'll get this value.
Okay, sir. Okay. Got it, sir. Thank you, sir.
Okay, so thanks everyone. So thanks for listening patiently. And yeah,
thank you for this wonderful session, sir. Thank you.
Thank you, sir.
Thank you for your time, sir.
Thank you for this wonderful session, sir.
Thank you very much, sir. Thank you.
Good night.
Yeah.
Good night, everyone.
Good night, sir.
So one last one. I hope some of you have attended this Python sessions I do, right?
Yeah, I have attended session.
Okay. Some of you are there.
Hey, which one? Attended one?
I have taken the Python. I'm the course instructor for Python.
Yes, sir.
Yeah.
Okay. So yeah, I just want to know whether I've done that better or this better.
Okay,
sir. Both of them are better, sir.
Yeah, both of them are really nice.
Awesome, sir.
Awesome, sir. Yeah, your sessions are awesome.
More enjoyable.
Yeah, you've done justice to both.
Thank you for that much effort. Thank you so much. Yeah.
Thanks.
Thank you, sir. Have a good day.
Thank you, Mr. Ram. Good night.
Are you there? Hello.
Hello. Are you there, sir? There's no sound.